today we will discuss some important points regarding drawing creation and detailed creation. Here we have the 3D models that we created on the previous day of training. And here we have the internals. If we take a half section inside this model. Okay. We create that on the previous session, and we will discuss how to create a part like this by using the sheet metal and import it to our 3D model. After that, after the session, I created those anodes and add them to the 3D model. Now, inshallah, we will make 2 more steps for the 3D model because the storage tanks team we don't discuss this point during the session of storage tanks module, which is adding some external items to the 3D model. Here in that model, we have some plates below the sliding saddle. So how to create those plates and import them to the 3D model, and how to add external items to SEG bill of material to reflect them in your drawings after that on the last step of drawing creation. Now, as you can see, if we select one of those saddles, for example, we will not find an option here to create those items below the base plate. So how we can generate those items and import them to the 3D. You have 2 different ways. The first way, by using SEG helper library, and you will find it when you click on new button. You will find a folder here called SEG items template. If you open it, you will find some subfolders like accessories, and here you will find some items like base plate, bended tube, washer, earthing lug, eye bolt, and some other items. For the bolts, here you will find bolt, J bolt, stud bolt, nuts, and U bolt. So if you would like to make a detail for the J bolt for saddle fixing, you can use those items. For the crossbee shackles, you will find some standard crossbee shackles. And we will discuss that in detail, inshallah, how you can use those items by checking our lifting lug that we already create. For the blades here below the sliding saddle, let's select SEG items template, and from accessories, let's open the base plate. Okay, after opening it, you will find the 3D model of this base plate, and here from the iLogic tab browser, you will open the form of this base plate from the Forms tab. If you have this form, as discussed, if we close the iLogic tab or it's not appear in your side, you can get it appear from the View tab. So you will need to move to View tab, okay, and from the User Interface button, you will get this list here for the all browsers, and from here you will need to select iLogic browser. So when you select it, it will appear like that in your form. So it's a drag and move tab, so you can move it any side like that, make it on the other side. So you will get the iLogic tab in your side by that way. Now when you open, you will find some tabs here like Rules tab, which include some coding, the iLogic coding for features, and the Forms tab. So from Forms tab, you will click on base plate form. So you will get this form. You can define the length and width from here. So let's check the dimensions of the first plate. We have here first plate, which is item S16. So let's go to the bill of material, and here S16. Here we have the length 2698. So here the length 2698, and for the width it's 606. So define the width, and finally the thickness. It's 3 millimeters thickness. So the thickness is 3 millimeters. Here the hole diameter is 48. Okay, is it a slot hole or a straight hole? You can define that from here. So you can define the slot hole from here, and here the slot length. Okay, and here the hole location from the short edge, as we find it in SEG. For example, here you will find two parameters to locate the first hole from the short edge and for the long edge. So from here, let's define the offset from the short edge, which is this one. Okay, let's make it the same with this saddle, but you should take care that the base plate length is differ from the other one. So let's decrease this value here. The length will be like that. So the offset value will be decreased, which is that value. So we need to decrease 7 millimeters. So we will take that and decrease 7 millimeters from it. Let's take a copy and make that as 1. And that will be half the value, which is will be like that here from the long edge. Okay, and the number of holes is 4. Okay, and it's in no single row, it's a single row. And from here you can define the part number description of this one, which will appear in your drawings for if you add a balloon for this item, like that balloon. If you would like to add a balloon like this, so the number that you will define it here, which is part number, that value will appear on your drawing. Now let's save this part. If you try to click on save, okay, we discussed that with the pressure vessel team on the previous session, but for the storage tank we didn't discuss how to create a new part and import it to the 3D model and reflect it in SEG bill of material. So we will need to discuss this point again. So if you try to click on save here, you will not get a response because now SEG is controlling the Autodesk inventory. So to save, go to SEG, and from Assembly tab, you will find Save Active Document button and save all documents if you have multi-documents opening, or make a save as or save copy as if you would like to export with the different extensions. But here we have we would like to save this part as a part from Autodesk Inventor. So let's click on Save Active Document and come back to Autodesk Inventor. You will find this form. So from here, let's save it inside the external parts, that folder we created last session, and create the clips washer, and we add some parts here. So from here, let's save this as sliding saddle plate. Okay, and save this one like this. Now we have this part by that way. Let's add it to SEG library or bill of material. So from tables here, let's open the bill of material, and from this form you will find a button here called extra bill of material. So when you click on this button, you will get this form, and on the previous session we had the grounding lug, which created manually. By the way, we create the grounding lug by 2 ways. The first way from SEG itself directly. Let's move this section. So we add this one from SEG, and that one by hand, to show you if you would like to add some items manually, what can you do. Now let's come back to SEG. Here we have this list. First point, you should select the vessel from this tree, and from here you will add your item, which is the sliding saddle blade. We have a single blade, so here's the quantity, and from here you will add a description for this one, like sliding plate. And for the technical characteristics, it's a plate. And you can define the length, width, and thickness. So here we have the length and width. Okay, so let's describe it here. Okay, that's the technical characteristics of this one. Here, the blade. And here's the weight of this blade, so we can get the weight from here. You will open the eye properties of this part from this quick access toolbar, and as discussed, you can get it from here, from this button. You can add the eye properties to the quick access toolbar, or you can get it from the file tab. You will find eye properties here. After getting this form, you will go to the physical properties and update the weight and area volume. So you will get the weight of this item here. It's 38 kilograms. So from here, let's modify the weight to 38 and give a part number for this one. Let's name it as a sliding blade. You can give it a part number or add remarks. Now, when you click save or update, you can figure that it will be included in the external items in your bill of material. If anytime you would like to make a modification, just select the node from this tree and modify the value and click on save and update. Now, if we close this one and go down here, you will find that you will have the sliding blade listed in SEG bill of material. Okay, now let's include this part to the assembly of the saddle. So now let's open the saddle assembly from here. And now we have the assembly of this saddle with the stiffening ring. Let's add the sliding blade. So from here, let's open this one and select place items. And from external parts, let's select the sliding saddle blade. Let's include it here in this drawing. And now let's add some constraints. So from constraint, let's make this surface mate that surface. After that, here, let's make this one offset from that one as flushed with a negative value 3 millimeters. So you can figure that it's from here it's 7 millimeters, sorry. So it will be like that. And from the other side, it will be 3 millimeters. So let's select this one and that one and make the offset with 3 millimeters. Now we have this sliding blade like that here below this saddle. By the same way, you can add the other plates. Now let's save this saddle. When you close it, it will appear here on the final assembly. Now, as you can see here, this this grounding lug is separate from this saddle. So if you would like to include it in the saddle drawings, so if let's open the saddle assembly here, we open it, you will not find the grounding lug. So if you would like to include it here on that assembly to make it appear inside drawings, you should include it by the same way to the saddle assembly. So let's include it here. After that, let's make a constraints to assemble this one. So from constraints, let's include those items. Here we have an offset here, let's say 200 millimeters. And finally, let's make this surface made that one is 150. Now we have this grounding lug here. So now you can delete the grounding lug from the assembly. So you can select it and delete, and you can figure that you have the lifting lug on the saddle itself. Now let's close this. And on the next step, we discuss how to generate a group to prepare a drawing for assembly. On the previous session for the pressure vessel, we discussed how to collect those items inside one assembly. Here we have the manhole flange, the nozzle itself, and the blind flange of the gasket. How to collect all of those items inside one assembly. For example, we still have some nozzles here, like this nozzle, this clips, this blind flange. You can figure that those are separate items. So how to collect them in one assembly? Here, this nozzle name is N9. Okay, so let's collect N9 with its attachments in one group. So let's come back here to SEG library, and let's look for N9 nozzle. Here we have N9. Okay, and now we would like to include those items inside one group. So to create a new group, we will need to right click on this nozzle, and from group options, let's add new group. Okay, and you will find a detailed video for the group options. You will find it here. In this video, you will learn how to create a new group, delete the content inside this group, or delete all the group, how to update or include items to the group. So group options, you will find it here in that video. Now for this nozzle, let's create a group. Let's select the nozzle, and from group option, let's add a new group and define this group is N9 detail. Okay, that's a new assembly. We will generate it, and that assembly will include those items for this nozzle. So let's select N9, and finally select the last part. Here we need to include it, which is the coupling. Okay, so from here, let's click on save, and now you will figure that we will get here a new folder after making the updating here. You can figure that now we have a new folder. If we take print screen and comes here, you will find here a new folder generated. It's sub-assembly, okay, called N9 detail, and that one includes on its structure includes all items inside this nozzle. Okay, so now you can figure that you have the nozzle N9 assembly. After that, all items are connected to this nozzle. If we come back to Autodesk Inventor, as discussed on the previous session, you will find this nozzle disappeared, or it comes here, but you have a miss assembly. Where is the cover? Where is the lug? So as discussed on the previous session, we will need to make an update for this assembly. So let's go to Assembly button. After creating this group, let's click on Start Assembly to update the assembly of this nozzle. As you can see here, SEG will collect those items inside one assembly. Now, if you take a look or select this one, you can figure that it's selected as a single assembly. If you open it, you will find all items here collected inside this assembly, and this assembly named now as N9 detail. Okay, here the name of the assembly, and inside Autodesk Inventor 3, you will find here a new assembly. Let's take here and come down. Sorry, take a look here. Here we have the assembly of the sand filter, and here all items inside this one, it's inside that level. Okay, so that level includes the nozzle and flange, gasket, blind, cover, clips, coupling, and the other connections here. They will appear inside this nozzle. So in that time, you will be able to generate a detail for this nozzle as a separate detail. And if you would like to export a bill of material for those items, they will appear inside your drawing. So by that way, you can create a group to describe a detail, a new detail for some items in your 3D model. On the previous session, we create this nozzle as a group after adding it inside a group. Now let's add a David for this nozzle and add some items like sub bolts and hand grips. Now let's come back to SEG. This nozzle is named M1A. So from here, let's go up there and select M1A detail. And you can figure that we have a group. After that, inside this group, we have the nozzle, flange, gasket, and cover. Now let's select the manhole, and from elements, you will find here some attachments you can add to the blind flange, like nozzle with external projection, nozzle with external and internal projection, some types of lifting lugs, hand grip, manway davit, and a detailed manway davit. Here, finally, the stud bolt. For the manway davit, you will be able to generate a manway davit, but it will appear as a single part. No details inside. It will be as a single part. No sub items inside it. But if you select the manway detailed davit, you will get a detailed davit component inside your bill of material. For example, let's add a manway davit. Let's add M1A davit, M1 davit as a single part. And from here, when you select it, you will find some options for or some different configurations for this one. In our case, it's a vertical one, so you can select this shape, for example, and define the outside diameter of the pipe, define the orientation, and click on Save. Now, if you open the tables and open the bill of material and go down here, you will find that you will have this davit appear here. Here we have this davit, and it will appear in your bill of material as a single part, which is manway davit type C. And here the material is assembly material, and you will get the weight here after creating it on Autodesk Inventor. So you can figure that the davit will appear here as a single part, no details for. Let's delete it. Okay. And before that, let's check the number of items. Here we have 86 items. Let's take a print screen from this one and copy it here. And you can figure that we have this one, which is the davit. Here it's item 83, and the final part here number is 86. So we have that's the final item number. Okay, now let's come back to SEG and delete this davit. So let's delete it, and let's add a detailed davit. Okay, so from here, let's select manway detailed davit. So let's add M1A davit. And now when you select it, you will find some standard davit according to standard specs like VIP and some other standard. So you can select the suitable davit which suits your case. After that, define the dimensions of this one if required. But because it's based on a standard, you just will need to select the size, select rating, select size of the nozzle. Automatically, the dimensions will appear here based on the standard, which includes the standard dimensions for this item. But if you would like to modify on those dimensions, like if you have a different rating, higher rating than that, or a size larger than that. So in that case, you can use this checkbox, which is user-defined dimensions, and now all fields will be open. So you can modify the values for the standard values of this one. Now let's keep the dimensions as they are, and when you click, sorry, it's a vertical one, we need to select another davit option. So let's select this one, keep the rating and size as they are, and now let's click on Save. Okay, now if you open the bill of material here and comes down here, you can figure that the last item number now comes 94. Let's open another one, and here if you take a look, you will find Here, that's the vertical davit items. Here, all of those items related to the vertical davit. Let's change this one. Okay, changes the color. Sorry, again, here that's the vertical davit items. Okay, if you take a look, a near look here for that vertical lug bolt, so those are items related to the vertical davit. They start from 83, so all of those items for the davit, if you take a look to the previous image, it will appear as a single part here, no details inside this one, and you can figure that the last part number was 86, which is a sliding plate, but after adding those items here, the sliding plate number changed to be 94. Okay, so by that way you can add a detailed manway. It's based on what you would like to create. If you have a standard, let's say if you have a standard drawing for the manway, it's a standard one. Just you will need to change the title block and send it to your fabrication workshop. So no need to create another drawing. It's a standard one. In that case, you may need to make it as a 3D model only on your model. No need to make a detail for it. But if you would like to create a detailed drawing for this manhole davit, so in that case, you will need to make it by that way. Now, after creating it, let's save this one and create it on the 3D model of this one. Now you will figure that this davit will be generated in your model. Here you can figure that the items will be generated each one separately. And if you take a look to the tree on the left-hand side, you can figure that each item of those will be created and assembled. And each one will get a description and a separate detail part number inside the bill of material. Okay, after generating the manhole, we will discuss how to make the nozzle opening inside the for the 3D model. Okay, and we will check some important points regarding the weights of items. Okay, here we get the manhole davit for this nozzle like that, and you can change the orientation of this davit from the orientation button here. You can define the value of the orientation for this davit to control the orientation of this one. Now, after creating this, if we take a section inside for this vessel, let's take a half section like that, and let's take a look for the nozzles from the inside. You can figure that we haven't an opening here inside this head. The same for the other nozzles, no opening. The main item, which is the head or shell, not include any openings. So, for example, let's open this head. You can figure that no openings inside this head. So, to make an opening for that one, you can generate that by using SEG software. You will get a tool to generate the nozzle opening. But before that, let's discuss one of important points regarding to the bill of material. If you open the bill of material here, you will find here that item. For example, here you have two identical ellipsoidal heads. They have the same description. They have the same technical characteristics. Same inside diameter, nominal thickness, minimum thickness after forming, and straight flange. They have the same material. They have the same weight. Okay. That's before making a cutting on each head. The same here for those 3 sheets. Okay, they have the same inside diameter, same thickness, same length, and same description, same material, same weight. Now, if you make a change by changing or creating creating a nozzle opening for each item of those, the weight of each item will change. If you take a look at the 3D model, if we make an opening for this nozzle inside this head, okay, over this head, you will get a cut here. This cut will change the weight of this head. The same when you make a cut for those nozzles inside this head, the weight of this head will change. That means this head will not be identical to that one because the weight is different. Okay. In that case, SEG will detect that those heads are separate heads, not identical items. Okay. The same here, we have 3 shell courses. They are the same information. They are the same weight, same material, same thickness, same inside diameter, all things as they are. But when you generate an opening, the openings for inside each shell, here you have this nozzle, another nozzle here. So the opening based on those nozzles will change the weight of this item. And it will not be identical with the second one, and the same, it will not be identical for the third one. So in that case, if you take a look here for the bill of material, those items, they will not be identical anymore if you make a nozzle opening, because the weight of each item will change. Now let's proceed creating the nozzle opening here. So from this form and from the assembly tab, let's open the openings form. Okay, when you open the this form, you will get this dialog box. When you click on load, SEG will load the list of nozzles. For example, here you will find the vessel name. You have the sand filter vessel. If you have another vessel inside this project, it will appear here. But those are the nozzles on the sand filter vessel. And on the right head, you will find a nozzle called N1. On the right head, you will find another nozzle called N2. And the type of this nozzle is nozzle with internal and external projection. So the type of this nozzle will appear here. Do you have any process like make a cut for this nozzle or not? It will appear here. No opening created for this nozzle. And here the type of cut. Okay, and that value will be a default value. And for if you define a distance, for example, you will find a list here, to next distance and all. And if you select a distance, you can define the distance for cut. And all of those options, you will find them discussed on another video here for nozzle opening. Okay, the options of creating a nozzle opening. And here the clearance between the pipe outside diameter. For let's make a new drawing here. For example, if you have that's the nozzle outside the diameter, and here you have the let's say that's the vessel. Okay, and you would like to make a cut on the shell, so you may get a clearance here with, let's say, 2 millimeters greater than the nozzle diameter. Okay, let's make it clear a little bit. So you will need to make a cut for this nozzle with a diameter greater than, let's change the color line. So you will need to make a cut with that diameter, okay, for the nozzle, and you will need to define the clearance here. So if you would like to define the clearance, you can define it here separately for each nozzle, or for all nozzles in one time from here. So you can create a cut clearance. So from here, create 2 millimeters as a cut clearance and apply this cut for all nozzles. When you click on to all, you can figure that this clearance changed here for all nozzles. So all nozzles will get the cut clearance on this list here. Okay, now if you we will not select this option, which is analyze interference, because all nozzles we add it on the main parent. Like for example, here this nozzle we locate it on can 2, okay, and this nozzle located on head 1. This nozzle located on can 1. Okay, but if you create it on CAN1 and in real location it's located on another shell, in that case you will need to click on Analyze Interference, and you will find all of those options discussed on the video of the nozzle opening. And to save the time, we will create it without selecting this option. Now when you click an extrude option, SEG will start creating the holding, make some calculation to collect the data from the SEG file and collect locations of nozzles, orientation of nozzles. After that, SEG will create a cutting for items on the 3D model. This process depends on the number of elements here. SEG start creating a cut on for the first head. As you can see now, automatically a new sketch created on that head and create a cut here for the shell for the first can. Okay, and for the second can, all nozzles for the second can. Okay, as you can see, this process, if you try to make it manually, it will take a time from you, but here in SEG, it will save a time if you would like to make this cut automatically by using SEG software. And by the way, inside the video of the training video for nozzle opening, you will find some points regarding the restrictions of using this part. Here, if you take a look to those items here, you can figure that you have a cut on this head. For example, if we open this head, you can figure that now you have a cut on this head. Let's open one of those shells. So if we open this shell course, for example, if we open it like that, you can figure that we have the opening here, another opening at the top. The other shell, if we open this shell, you can figure that you have an opening for the manhole and the other two nozzles. If you get sheet metal development or flat pattern for this one, you will get a developed blade with a nozzle cut like that. And as discussed, you can export it as a sheet metal by exporting it as a DWG or DXF extension. Or we will discuss how to make that by using SEG tools. Okay, now we generate the nozzle opening. If you would like to delete an opening of those, for example, you will open this form again and load all nozzles. After that, you can deselect all, for example, and for this nozzle, if you would like to delete the opening of this one, here you can figure that the process you have a cut for this one. If you would like to delete it, just select it. This is checkbox and from delete. So that means this opening will be deleted. That's in case if you would like to delete one of those openings, for example. Now let's check the bill of material after creating the nozzle opening. Here, if you open the bill of material, you can figure that, you can figure that here. Now you have two ellipsoidal heads, not a one head, because they become not identical. Here you have the weight of the first one. If we take print screen here, for that head, you can figure that the values are different. They not become anymore the same because you have a different cuts in each one. For those identical shells, okay, after creating the opening, here you have the same inside diameter, same thickness, same length, but here you can figure that the weights are different. So SEG automatically will separate them because they not become identical anymore. Okay, so this point you should keep it in your mind during creating the openings, because it will reflect on the bill of material of your model. Now, if we come down here, you can figure that the number of items, the last item here, number now changed because you have 3 items new 3 items created, which is the second head. Now it's separate as a separate part. You have 2 more shells separate because both of those 3 shells was indicated as 1 item, but now they are 3. So you have 2 new fields here for the shell. Okay, now after creating the nozzle opening and discussing the reflect of that on the bill of material weights, now let's discuss another feature, which is creating a flat pattern. Here, let's save this. Let's save this simply. Okay, and now when you try to get a flat pattern, now SEG will inform you that we will need to close the assembly. So let's close it. After that, when you click on scan parts, from this form, SEG automatically will search inside your project for all sheet metal parts, and you will get a list for all sheet metal plates here. SEG will open the parts and check if it's a sheet metal or not, and all sheet metal parts will be listed here on this form. So if you would like to generate DXF or DWG drawing for the sheet metal parts, and after creating the scanning, let's check that. For example, let's select some nozzles, some shell blades, and export them in DWG. You will learn how to make this step. Here you can figure that all items now checked and listed. Here SEG open all items and check if it a sheet metal part or not. Okay. Let's wait a little bit to complete the sheet metal scan. Okay, we can abort that or stop the that one. So at this point, and from here you can select the required items like those. Let's select those rebads. Okay, select the nozzle next from here. Select this shell course, the wear plate of this saddle. Select the whip of this saddle, and now you can create the or you can select all from this checkbox. By that way, you can select all plates from here. After that, you can select the extensions that you would like to export, like DWG or DXF. Let's select DWG, and from here, click on Export Sheet Metal. Now, let's select the project, which is that one, and let's create a new one, DWG, for example. Okay, and select this folder to export the sheet metal parts. Now, SEG will open the parts and get the development of it and export it in DWG extension. And if we come back here to the project on the desktop after creating those items, okay, so after creation, let's SEG will inform you that the scan is done. If you would like to close the form, you can close it. If you would like to export some items, click on cancel, but let's click on OK to close the form of the scanning. And if you open the this folder, we have here a DWG file. And if you take a look inside this folder, so let's open this one by using the AutoCAD application. Okay, you can figure that you have the sheet metal development of this shell, and here the bending line. Let's open another one for nozzle, for example. Let's open the fixed saddle. Let's open those drawings. Okay, here you have the cut for the nozzle neck, another one for the rebad for nozzle M1B rebad, and here M1A neck, and here M1A rebad, and here for the web of the saddle, and here the wear plate of the saddle, and another shell course for CAN 2. So by using this tool, you can get the sheet metal development of items. Let's close the AutoCAD, and now let's come back to SEG, and let's make a nesting study for some items. We discuss the nesting options with the storage tanks team, and here let's discuss some of those options with pressure vessels team, because we didn't discuss that. Let's create a new assembly, for example. Okay, and let's add some items here, like let's take a copy from this saddle and add it here. Okay, and for this manhole and that one, let's take a copy. Okay, let's take a copy from one only, and sorry, take a copy. Okay, and add it here on that assembly. Now we have those items, and we would like to make a listing for that. So from here, when you select the assembly tab, you can create list. So we will need to save this part, this assembly first. So from save, if you try to save, as mentioned, you will not get a response. So you will need to come back to SEG, and from here select save active document. And when you come back to Autodesk Inventor, you will get this form, and name this assembly as listing study 1. And now let's create a nesting study, and from here let's make it in millimeter and click on OK. Now you will figure that the nesting tool will collect the items based on thicknesses and materials, and after importing it, you will get here you will get those items inside your model as a separate parts. Now you are ready to make a nesting for it. And in detail, kindly watch the nesting videos for that one. So by that way, you can collect the items and study how you can make a nesting. For the training video for the storage tanks, we discuss that, and you will find another videos discussing that in detail, how you can define the delivered plate dimensions and make the clearances for cut. Now let's go to the next step, which is making or creating the drawings here. And that's the main points for today's training, inshallah. So how to prepare our template and create the drawings. It's a general point here. If you would like to generate a drawing for each node in SEG, just select this node from the tree and right click, and you will get this shortcut menu, which includes the drawings. And now you will be able to create a drawing for this node. Okay, so in that case, if you select the flange, you will be able to generate a drawing for this flange. The same will be for example, for a group, like the detail nozzle for nozzle N7. So you can generate a detailed drawing for this nozzle, which includes the nozzle, flange, gasket, and the blind. By selecting the group node and click on create drawing and select create drawing, you will be able to generate a drawing for this group. And the same for the vessel. If you select the vessel and right click on it, you will be able to generate a drawing for this one. From here, you can create a drawing. So how to create our own template, okay, based on SEG template drawing, because SEG template drawing includes balloons, samples, welding samples, and a lot of information will not be included in your drawing. So how to use SEG template as a reference and add your title block and border inside this drawing. Okay, now let's select any item for, like, for example, for this flange, and right click and create a drawing for this one. Okay, and keep all information as they are. Just remove the nodes and the welding and create a drawing for this one. Let's come here and save that. Okay, and create a drawing. Okay, now you will get, sorry, it's another template. So let's remove this template from SEG first. Let's close this. And here for from the setting, you will find here a custom drawing. And this form, you can include a custom drawing for your case. So let's delete this one. We used it on another training. So let's delete it. So now no references. And now when you try to create a drawing, let's delete the created drawing here and create a new one. From here, let's create a new drawing based on SEG drawing. So from here, keep everything and create a drawing. Now we have SEG standard template. Okay, and now let's use this template as a reference to add our template and border, title block and border. Now this drawing now is saved. So let's go to inside our project, day 7, and inside drawings folder, you will find here a folder called sand filter, which is the vessel name. When you go inside, you will find here this drawing, which is N1F2, which is a node name. We create a drawing for N1F2. So this drawing for N1F2. So let's take a copy from it. And inside drawings, let's paste it and name it as template reference. Okay. Now we have this new reference. Let's open it in Autodesk Inventor, and let's delete the revision table, delete this nozzle, and delete the title block and the border from here. Okay, or you can modify on the border and the title block by go inside the title block itself and make editing, like deleting this one, deleting this text like that. Okay. Now you have this border, and you can make a modification like adding here your name, like, and define the length that, and add a text, for example, here like SEG Solutions. Okay. Okay. Now you have this text. You can align it anywhere. You can decrease this 140, for example. So you can make your modifications like adding here, let's say add triangle. So add the middle here. Let's select this point and make it from the edge. So let's select it again and make it on the middle. Make this line as a horizontal line. Change that. Make it 5. Make it hatched. So let's select this one. Make it solid. So you can make your modifications to this border and save it, and you can give it a new name like SEG Solutions. Okay. And for the title block, you can do the same. So let's edit on that one, or you create your own border as discussed On the last day on Autodesk Inventor training, we discussed that in detail for title block and border. And now let's edit this one. So let's delete those the logo from here, and let's import and or keep it as it is. Make some modifications on the height, like changing that to 80 millimeters, for example, adding a new rows here like that. Okay, and modify this title block as discussed. After that, you can click on finish. Now you have a new title block and border based on your reference template. After saving it, close it. Okay, and let's close this one. Okay, and now you have a new template drawing here. You can use it as a reference. So how to use this one? From here, let's open SEG, and from the settings tab, you will open the custom drawing. From this custom drawing, you can import your template. You have the ability to add any number of reference templates. Okay, let's add the first one. From here, let's select the template, and from here, let's select day 7 and the drawings folder. And here we have the template reference. Okay, and let's add reference 1. Okay, and here you will need to define those values here in centimeter. So let's open the border again. Okay, and check those values. So how to check those values? For the border, let's open the border itself. So from edit, let's open edit, and you can figure that it's 8 millimeters, okay, from top and side. So all sides is 8 millimeters. So let's come back to SEG and define the values here for the border gap. It's 0.8 centimeter, which means 8 millimeters. So the values will be entered in centimeters. So let's keep it like that. And for the title block height and the title block width, let's check them from here. Okay, let's make edit. And here the width is 17 centimeters and the height is 8 millimeters. So let's come back here, 17 centimeters and the height is 8 centimeters. Okay, so after defining this, why we are defining those values? Because SEG will start arranging tables. Here above this one, you will get the revision table. Above it, you will get the bill of material table. So all of them will be located on the defining values for your border. So the design data table will start from this point. So SEG will need to know the offset from the edges here to locate the design data. The same for the nozzle table. So those values, SEG will use them to locate the tables inside your drawing. Now let's append the modification here. So from here, let's click on append. Now you have this reference listed in your templates or reference drawings. So after selecting it, let's select it and set it as default. So when you click on set as default, now any drawing you will create it, you will use this border and title block or this reference drawing. Let's add another reference drawing. Let's take a copy from this one. So from here, let's take a copy and make it as a template reference number 2 and open it and make some modifications on the border and the title block. So from here, let's create another on the border itself. Let's modify the values. So those values, let's change them instead of 8 millimeters. Let's make them as 10 millimeters. From here, let's make it 10 millimeters, as you can, or 15. Let's make it, for example. You can figure that the offset will change. Let's save this border. And now let's come back to the title block and edit this offset. Let's make it from here and change the height. Let's make it 100, for example. And for the width, let's make it 2000, like that. And click on Save Title Block. Now we have another title block with different dimensions. To include it from Custom tab, let's select this one and select Template Reference 2. And from here, give it a name as Reference 2. And let's modify those values. So here we make it 15 millimeters. That means 1.5 centimeter. 1.5 centimeter, and for the height we make it 10 centimeters, and for the width it's 20 centimeters. Now when you click append, it will be included. Anytime you would like to use this border and title block, just select it and set as default, and you can figure that the checkbox now move to this one. Again, let's select this one and set as default. It will be changed. Anytime you would like to modify the dimensions here, you can modify the value and click on update. For example, let's change this value and click on update. Automatically you can figure that it's reflected here. Let's get it back again like that and click on update. You can figure that it will be reflected. Okay, now let's start creating our first drawing by using the first border. Let's close this one, and the same for that one. Now let's generate the general arrangement drawing for this vessel. How to make that? As discussed, you will need to select the vessel node from the tree. That's the first point. After that, right click to get the shortcut menu, and from here you will select drawing and select create drawing, and you will get this form. This form give you the ability to select some features, like the first one, selecting the drawing size. From here you can select the size of the drawing if you would like to make it in metric sizes, standard metric sizes like A4, A3, A2 up to A0, or you can make it in English sizes like A, B, C, D, or you can make it as a custom size in inches or custom size in millimeter. So in case of selecting a standard size, you will find the values here as standard sizes for A1. But if you select a custom size in millimeter, those values will be editable. So you can define the length and the height and the width of the drawing that you would like to create. Now let's select A1. And from that side, you can define the orientation of the drawing. You can make it as a portrait or landscape. You can change the location of the title block. You can make it on the left-hand side or right-hand side, make it at top or bottom. So you can change the location of the title block. So that's the first tab, which is sheet data. Here from the active views, you will be able to add the views that you would like to include it in your drawing. Okay. For example, here you will find 9 checkboxes. You can select between them up to 4 checkboxes only. 4 views inside the drawing. After that, you can add any other view manually. For example, here we will need to add a view for the vessel from that view, which is the elevation view, and add another view like that, which is the back view for this vessel. So from here we will need to add a side view. So we will get 2 views, the elevation view and the side view. And from here, let's create a spacing between the vessels. Okay, between the 2 views, let's make them 4 centimeters. And here you will find a note, which is all spaces are in centimeter. Okay, here this note in this form below here with a bold color, bold font, because any value you defined it here, it will be in the centimeters. After that, you will go to the next tab, which is defining the orientation of the elevation view. What does that mean? That means here, if you select, for example, the left view, that means the elevation view will be from the left view, which is, you take a look from the cube view. That means if you take a look from the left view, the elevation view will be like that. For example, if you change it and make it front, so that means the elevation view in your drawing will be from the front view. Okay, if you make it top view, the elevation view will be like that as a top view. So that will be the elevation view in your drawing. So the correct one in our case, we will need to make it from the left view. So let's come back here and select left view, which will be the elevation view. So that view will be the elevation view. And after that, let's define the style. From here, you can make the style with hidden lines, or you can make it with visible lines. You can make it with shaded color. So in your drawing, you will get the true color here in your drawing for the material. And in case if not, you will not need to change that. Select this checkbox. So all lines will be visible or visible with hidden lines. So you can select the style from. Now for the elevation location, you will add rough values for the elevation and the location of the elevation view in your drawing. It's in centimeters. That means, for example, let's open this template here. And for example, if you have a view, it will appear like that here on this area. So the location will be referred from here to there if we add another point here and fix this point like that. So the location on X direction, it will be that value in the centimeter. So let's make it centimeters, for example. Like that. So that will be the location of the view, and from the height, which is Y, it will be, for example, like that. So that will be the start location of the view, like that. So if you make it 0 and 0, it will be located at the edge here in 0 and 0. So the elevation view will be here, and the other view will appear on the other side like that, or other like that, or at top. That depends on the selection of views that you would like to make it. So the location of the elevation view, you can define it from here. So let's make it, for example, let's make it leave this value as 20 and make this one as 30 and change the scale. Let's make it 24, for example. Okay, those are some rough values. We will change them after creating the drawing. Okay, the next tab includes the tables that you would like to export. Here you will find on the right-hand side the bill of material table. So if you select it, you will export the bill of material table to your drawing. And from here, the design data, you can export the design data. The nozzle table, maximum allowable nozzle load, if you have nozzle load defined in your project. And fitting table, gasket table, pipes table. So if you would like to modify some of those, you can select it. If you would like to include some of those tables, you can select them to make them appear inside final drawing. And for the notes, you can add your general notes. So if you open this form, you can edit or modify on the current standard notes. So for example, if you would like to delete, just select the row and from here select delete to delete it. Or if you would like to add a new one, like adding a comment here and add it so it will be included. So by clicking on that, you can re-edit to modify it, or you can select it and delete to delete it. And you can import from an external Excel sheet. Now for the welding details, you will need to open the welding details library and select the required welding details for your model. For example, here you will find the details for longitudinal and circumference welding lines. Here, the longitudinal and circumference welding lines as a single V. If you have a double V, you can select other welding details. If you have a clad, you can select other welding details. If the welding from inside or outside, you can select the welding details suits that. A connection between cone and shell. Flange connection with a pipe. If you have a clad or a single V or double V, you can select the required one. If you have different thicknesses, like if you have a shell with a head with a different thicknesses, or you have an insert bed for a nozzle with a shell with a different thicknesses, so you can select the suitable welding detail for the step-on flanges, elbow to pipe, and a lot of details for the nozzles connections. And here skirt connections, external rebads, and the stiffening grips. If you have another welding details for the storage tanks, like overlap, and for the sketch plate with the bottom plates, Here another connections for the heat exchangers like tube to tube sheet connection or other stiffening external stiffening rings like that. So you will find a different welding details here. You can select between them. Here let's select this detail, for example, and that one. And for nozzles rebad, we have a nozzle with a reinforced bad, another nozzles with without a rebad, another nozzles with internal and external projection like that with reinforced bad. So let's select this one, nozzle with internal and external projection, and we have a reinforced bad. After that, click on save. Now we have we modified the welding detail styles that will appear inside our drawing, and from here you will find another list for client document list. When you open it, you will be able to, if you would like to include a table like that for the client document list, like if you have a process data sheet, mechanical data sheet, another specs, you can include it. Like here, let's add data sheet, okay, and define the document number like that, for example, and include it. So you will be able to include the documents that you received from your client. And from here, if you would like to add a table for the documents that will be submitted from your side, like the mechanical calculation, give it a number like that and click on add. The general arrangement and another one like saddle detail, okay, and give it a number. M1 detail, M1 detail, for example, give it another number and click on add. So you have a list for your documents that will be submitted from your side. Now, if you close this form, after selecting the tables, we will need to move to the next tab, which is the revision table and title block. So from here, let's give a name for this drawing, which is general arrangement, okay, and give this document a number like that. Okay, after that, from here, that's the revision table. So let's edit that value. It's revision 0 for review. And from here, you can have the approved by, checked by, and prepared by. After that, you can click on save. Now, if you would like to add some empty rows, from add button, you can add some empty rows like that for the revision table. If you would like to modify in one of them, just select it and click on edit to fill the that table with values. Now let's go to the next tab, which is the design style tab. In this tab, you will find here an option give you the ability to make your drawing from multi-sheets. Here, for example, as discussed on the last day on Autodesk Inventor training course, you have the ability to create multi-sheets here. So if you, for example, here you have a sheet 1, you have sheet 2, you can add another sheets here like that. So in each sheet, you will add some information. For example, on the first sheet, you will add the design data and the general arrangement for your equipment. On the second sheet, you will add the bill of material and the general notes. On the third sheet, you may add the nozzle table and some other tables. Okay. That depends on how you will think about exporting your drawings, how you will produce them. So it depends on you. So we give you some of flexibility for doing that. So for example, if you would like to make them in one sheet, just select the design one. And from here, all tables will be on the design sheet or the first sheet. But if, for example, if you select design 2, that means you will have another sheet. And for the second sheet, you can decide the size of the second sheet. For the first sheet, we decide that the size is A1. But for the second sheet, you have the ability to decide another size. For example, here, for example, for that one, we make the size of this sheet as A2. But for the second side, let's change that size to be, for example, A4. So you can figure that the size of this drawing now changing. The same thing, you can do it from here by deciding the size of the second sheet. And now you will find one more point appear here, which is you can move some of those tables to the second sheet. Here, for example, if you select the bill of material table, now you will be able to move this table to be included in design 1, okay, or 2. So you can move the bill of material table to the second sheet. If you add the third sheet, you will be able to define the size of the third sheet, and you will find that you can move some tables to the second or third sheet. Now let's make that as a design 1. We will need a single sheet only, and saving option is very important to give SEG the ability to get the location of each table after creation. Here, let's click on save. And for the last tab here, this tab used only in case if you have a sub-assembly, not the general arrangement assembly. Sub-assembly like saddle or nozzle detail. In that case, you can use this tab to make sub-detail drawings for the items. And we will discuss that for the detail inside the detailed drawings. Like if you have a support saddle and you would like to make a general sheet for the saddle assembly, after that make sub sheets for each part, like a sheet for base plate only, another sheet for the web only, another sheet for the wear plate only. So you will get sub sheets with the main sheet of the saddle. So in that case, you can use the sub sheet tab. Now here, after defining all information for this drawing, like modifying the drawing size, defining the required views, which is the elevation view and the side view on the right-hand side, the spacing between views, defining the orientation of the elevation, selecting the styles of lines inside the drawing, modifying the location of the view and the scale, by the way, here we select the required tables, add the revision table, and select the number of sheets. Now we are ready to create the general arrangement drawing. Now if we click on create drawing and come back here, you can figure that we used the reference templates that we generate now, and here we have the visual elevation appears on the drawing, and now the bill of material now created. Okay, here the bill of material list, as you can see, it's filled automatically, okay, with the values which generated from SEG. After generation, it will be located on the right place. As you can see for the revision table, for example, it's located over the title block, and it takes the correct place because you already modify the values of title block and the border, okay, during the importing. Here the design data table. As you can see here, the bill of material information is huge a little bit, and it takes most of the drawing space. So in that case, you may decide that you will need to separate the bill of material in another sheet. Okay, so you will have 2 sheets, for example. The first sheet will include the visual views and design data and some other tables, but the bill of material, you will separate it on another sheet. Okay, so let's do that after finishing this drawing. Let's repeat this drawing again, and let's try to move the bill of material on another sheet. Here, finally, after adding the nozzle table and notes, here we have the welding styles will appear inside our drawing. Okay. Now, as you can see, here we need to check the suitable scale for this one. So we can check it quickly from here. Let's change this scale to 30. So it may be a little bit good for here. So we can change the scale to 30 and modify the location. So it's in Y direction, it's okay, but it's in X direction, it is not. I think it's not suits our needs. So from here, let's come back to SEG, and from here, let's select the sand filter node, which is a vessel node. And from drawings, let's delete this drawing because we need to separate the C sheets. So it's a step before creating proceed with the final drawings. From here, let's click on create drawing, and you can figure that all information you defined is already saved here. We will need to modify the scale, make it 30, and let's make this one as 24, for example. And from design style, let's make 2 sheets. So from here, let's add another sheet, okay, and make the second sheet size is A3, okay. And from here, let's select the bill of material and move it to the second sheet, okay. So by that way, you can figure that all tables will appear in design 1, but for the bill of material, it will appear on design 2. Now let's save those information and let's proceed creating this drawing. So when you click on create drawing, you will get here, if you take a look to the image on the Autodesk Inventor 3, you will find here on the right side, you will find 2 sheets, sheet 1 and design 2. And here SEG will fill the information for the bill of material. And as you can see here, that's the bill of material during filling process. Okay, SEG filling the bill of material table. Okay, after filling it, SEG will proceed with filling the other tables on the previous sheet, which is sheet 1. Here, that's the bill of material. And if we try to open the sheet 1 from here, here that's sheet 1, and here the welding styles created, as you can see, and located in place. You can change the location and the arrangement of those items after that, but here that's the default option. Now you can see that the location of the vessel seems makes sense a little bit. We can move it a little bit to the right hand side, increase the spacing between vessels, and make the Y or the elevation location from the vertical direction little bit down to give us a space to add some dimensions here and there. So from here, let's come back to the vessel and create drawing. Just we will modify the location of this one. So let's make it increase that one like that, and the height, let's decrease it a little bit and make the scale, let's make it 28, increase the spacing to 6 centimeters, and let's check the location of this vessel after modifying the scale. Okay, let's move it a little bit on X direction. So from here, come back, and from drawings, let's modify the location a little bit. So let's make it on 30 millimeters and decrease this one, the location in Y direction a little bit, and check that. Now we have the location of the vessel will be like that. So we have an elevation view. Okay, that's the elevation view, and that's the scale. Here we have the side view for the vessel. Now let's add the annotations and dimensions for this vessel. So let's save this, and from annotations. Before going to the annotation, let's check the information here. For this title block, we add some parameters which we discussed, like the custom parameters on the last session of the Autodesk Inventor training. We discuss the parameters like adding a custom parameters here, and you can make them reflect on the border, or some sheet parameters that you can reflect it here. So kindly revise the last day on Autodesk Inventor training to check how you can control the values which appear here on the title block. Here we have the revision table, and it will be filled with the same values that you entered on SEG. Here, that's the revision table. And at top here, we have the design data table with the same information that we import. The notes table, client document list, and vessel document list, which include all information that you import. And here, finally, the nozzle table. Here you will find the nozzle service and the nozzle size, pipe outside diameter, and some information here, and we will discuss that in detail, inshallah. Here, let's add some annotations for this vessel, like adding the center line. So from here, let's add one of longitudinal center lines, and you can extend it up to here. From the other side, extend it to the other side like that. Add center lines for the nozzles. So from here, let's select this one, that nozzle, the saddle, to define the saddle location, okay, for that nozzle, okay, for this stiffening ring, for that nozzle, that saddle, okay, for this lifting lug, that support, here this nozzle, another nozzle here, this support nozzle. So in this training, we will make, inshallah, a complete drawing. So we will make a lot of details inside this training, inshallah, to discuss each detail, how we can make it. So here, let's increase the center line a little bit. From here, now let's define some center lines here on the other view. From here, let's select the vessel inside diameter. So we have that one. Let's add some center lines to define the location or the offset of the nozzles from here. Let's add some center lines for nozzles to define the offset. Okay, for this one here. Let's add a center point for this lifting lugs. We have here the anodes. So let's add the center lines for anodes, like that. And here we have the cross beam, which carries the piping. Let's add center line here for the support, another center line for that support. Okay, now let's add some dimensions and define the datum line for this vessel. Now let's add a tan line. So by using this type of center lines, which you can select 2 points. So from here, let's select this point and select that point to define the tan line of this vessel from that side, and the second tan line for the last head, and click on create. Now we have those 2 lines here. Now let's define the datum point. The datum point here will be located on the tan line on the right hand side. So from here, let's select ordinate type, ordinate dimensions type. So from here, let's select that ordinate and select that view. Now you can figure that you will get this center point or datum point, which located or work as a reference for the datum line. Now by adding it, you will be able to add some dimensions referred to the location of this datum line. So from here, that's the location of this stiffening ring or the first saddle. And when you select the center lines, it will locate the dimensions on the same level. So for like that. So all dimensions will appear in a vertical location like that on the same level. So let's add the center lines. Here we have the final lifting lug, and here we have that one. For the bottom nozzles, let's select the ordinate option again, and from here let's select the center line and move it a little bit down here for the saddle. So when you select the center lines, they will be located at the same line or the same level like that. Okay, now let's add some dimensions for the nozzle offset. So we have a nozzle here at the top, that one, and for the bottom nozzle, it will be like that. To define the projection of the nozzle, so let's select the facing of the nozzle from here to the tan line, and we will get the projection like that. To modify this projection, as discussed from the projection calculator, so from here, let's come back to the nozzle and select the nozzle M2 from this form, and from the calculator, let's open the calculator and calculate the actual projection of this nozzle. So if we open this one, it's 1180. So let's modify this value like that. But take in your considerations that the value here measured from the seam line, but in the AutoCAD drawings, it's measured from the tan line, not the seam line. So we need to increase this value with the straight flange length. So the projection will be like that. So let's come back to SEG and define the projection to be like that. Remove and click on calculate. Now SEG will calculate and get the actual height of this nozzle, which will give you the actual projection of the pipe. So let's click on save, and you can figure that the projection now reflected. If you click on start assembly, the projection of this nozzle will be updated to suit the projection of the nozzle. Okay. And now if we come back to the drawings again, you will find that the projection of this nozzle from the tan line, now it's changed. Okay, looks like this one. Let's add some other dimensions for the shell blades. Here, let's add the straight flange. So let's add this value, move it a little bit here, and add a text. So we will keep the value. As you can see, it's a parameter. No way to change it, which is the straight flange value, unless you make edit value. But here we will add just a text. So it's straight flange like that. So we have here 50 millimeters straight flange. Let's add the shell lenses. So we have here the shell lens, and from here to there, we have the second can lens and third can lens. And for the last one, it will be like that. Now let's make this datum line disappear. Okay, so how to make disappear? If you select any dimension related to that one and right click, from here you will find this option, which is hide origin indicator. So when you select it, it will disappear from your drawing area. Now we need to add some texts here, like referring the longitudinal welding lines, datum line, all of that. So let's select the visual view from here and click on S from keyboard, or click on sketch to create a new sketch on that one. And let's add a text here, which is datum line, and the elevation will be 0.0. So that's the elevation of this one. After creating it, let's rotate it counterclockwise, and here we have that datum. So that will be the datum, and let's add another text like tan line, for example, below that line. So that means you have the datum here, and the right tan line is the datum line. So you define the datum line from here. Let's add another text, like here we have circumference or circumference welding line 1, like that, and we have a longitudinal or seam line 1. Is that one? It's seam line 1, and let's rotate that one with counterclockwise degrees. So like that. And let's take a copy from this text like that and define the second longitudinal welding line orientation. That's the second welding line, third one, and last one. And let's modify the values. So from here, seam line 2, here seam line 3, seam line 4. Okay, and for the circumference welding lines, let's make the same. Take a copy from here to that line, for example, for the second, third, and here the last one, and modify the values. Now let's click on finish. We would like to include the center of gravity of this vessel on that view. So how to make that? If you select this view from the tree, okay, and by clicking on the right click and find in browser, if it's not appear here, for example, if it's not appear here, you can detect the selection from this list directly, or you can get it from here by clicking on find in browser, so you will get this view. Now you have this assembly. If you select the assembly from the tree and right click, you can get the center of gravity. So here you will get this the location of the center of gravity, the actual center of gravity for this vessel, and it's very accurate than the BV-Elite or the calculation software, because here the model takes in its considerations the openings of the nozzles and the internals here. In BV-Elite, for example, you will not add the internals inside this vessel or anodes or something like that, or platform clips. You will not add that in BV-Elite in detail. So the estimated location of the center of gravity will be not the accurate value, but here for the 3D model, you will get the accurate center of gravity for this. So to add a sample for the center of gravity here, you can use the sketch samples in SEG, and from here you will find in this list a CG sample, so you can import it by double clicking on this sample like that and get it in your area, located on the center, and now you have the center of gravity. To add the location of this center of gravity, by the same way you can open the ordinate dimension type, select the view and select that center line, select that one and move it a little bit down here, and now you can add a text for this one by editing the text, and here the accurate value, you will keep it as it is, but you will add it as fabrication equals like that, or add fabrication. Okay, and you can add another value at operating, for example, at operating equals, and add the new value at the operating. Okay, like that. So you will get here, identify the location of the center of gravity in the fabrication case and the operating case by that way. Now let's add some dimensions for the saddle locations from the 10 line, like that, and between this saddle and the second saddle. So we have the spacing, and for that one, like that. Now we have the location. Let's add a 10 line here on the other side by the same way. You can select that one, add this value, and you can right click on that one and copy properties. And this option will give you the ability, if you add a text or something like that, it will be copied to the second side. So from here, you will get a straight flange at this one. Now let's add the 10 line. So select the 10 lines like that. And from here, add a text 10 to 10, like that. So we have the 10 line. And if you would like to add the overall length, select the facing of this nozzle from here to the facing or to the end of this body flange, and from here right click and over all. Okay, so that's the overall length of this. Now you have that view, and now let's add balloons for elements. we need to define what is this nozzle, what is that nozzle. Okay, so let's select the balloon, and from here select nozzle tag. And from here, if you select this nozzle, for example, and select the parts only, from here, if you select this one, you will be able to add a name of this one, which related to the name of the tree. For example, here you give this nozzle a name, which is N5, for example. So this name will appear on the drawing view. Let's click undo again, okay, and make it little bit in detail. The first point you will make it, or first step, you should select balloon. Okay, after selecting the balloon, you will open this list, okay, and inside this list, you will find nozzle tag number, item number in bill of material, and part tag part number. Those values only will appear if you are using the SEG reference drawing. Okay, if you haven't that reference, you will not be able to get those. So here, when we read the template drawing, when we make a template drawing, which is that template, we used SEG reference drawing to define this one because it's already include the those balloons and some other standard styles for the dimensions here. For example, if we open the Manage tab and open the Styles editor, you will find here a list of tables, okay, for the bill of material list. You will find the SEG part list, for example, and you will find here on the table some tables like fitting table, design table, flange table. So if you create your drawing without based on SEG drawing, you will not lose those information. Okay, let's go this one. And now let's add the balloon. So from here, let's select balloon. After that, you will select the balloon tag, okay, nozzle tag number. This selection will give you the ability to add a tag for the nozzle based on the name in SEG tree. So when you select it and come here, for example, and select this nozzle, okay, you will get this list. In this list, you can add a balloon based on the structure, okay, and this structure will give you the assembly name, not the part name. So from here, you in Autodesk Inventor 2023, you will not find the structure legacy or parts only legacy. You will find structure and the parts only. So you can select parts only. Now when you select that one and move up a little bit, and by using a control from the keyboard, you can make it vertically. If you click on control, you can get the balloon in a vertical position like that. If you remove the balloon, you will not be able to make it in vertical. Okay, so to make it vertically, just click on control during porting, and now you have the ability to add it in vertical position. Now click, okay, and right click and continue. Now you will add the balloon. Again, for this nozzle, select this nozzle, move up here, and by using control, you can make it vertical. You can make it aligned like that. Click and continue. The same, let's make it here. So from this nozzle, select that one to make it aligned. Click and continue. By the same way for this support, for example, if you select this support like that, so let's add this support here. Let's add this support. You can move it a little bit up or a little bit down, so you can change the location of this one like that. And for the dimensions, you can select the dimensions as discussed on the drawing. The last session of Autodesk Inventor drawing, and make them aligned so you can move those dimensions a little bit up like that. So by that way, you can select the nozzle tag number here for this nozzle. For example, if you select this flange instead of the pipe, let's select this flange, okay, and move up here. You can figure that the balloon name will take the element name, which is N3 flange, because you select the flange. And here, for example, you selected this flange, which is N3F. Okay, so the name will appear in the drawing like that. But actually, you need the nozzle name, not the flange name. So in that case, you can make the next steps, which is selecting this balloon and right click. And from here, you will attach. You will attach another balloon. Okay. So from here, now you can select the nozzle itself, and you can figure that you can move the balloon around that one. So let's make it on the right side. So from here, you will get in 3. Now you will be able to remove the previous balloon. So let's select that balloon like that. And from here, right click to get this shortcut menu and remove the balloon. Now N3 balloon will be remaining on the drawing area. Okay, let's add some other balloons. So from here, if you try to add a balloon without selecting the nozzle balloon, you can figure that you will get a number. Okay, and if, for example, if you select part number, you will get that value. If you select tag number, you will get that value, which is the description of this element, which is plate with that length, width, and the thickness. If you select item number in bill of material, you will get the number of this part. And in our case, we need the nozzle tag number. So from here, let's create the balloon number, and the same we will do it with the second nozzle. Okay, here you can figure that if you try to select the nozzle, you will not be able. So let's select a flange and try to make the same steps by selecting this balloon and attach a balloon for the nozzle. After that, delete the or remove the flange balloon. Now, by that way, you will add balloons for nozzles. Okay. Okay. Let's go to the second view and let's define some dimensions for the nozzles offset from the center line. So let's extend this center line a little bit top like that. And now let's add the center line offset from this one from here to there. And for the platform support for the manhole, let's add this one, and from here to there. Now you have the offset from the center line. You can add the projection of the saddle or the height of the saddle from here. You can add the saddle bottom width. You can add the offset of those nozzles and those sides by that way. Now let's add the orientation of those lifting lugs on the vessel. So you can select the center line from here to there and define the So let's select this one from here to there and define the orientation of this one. So let's select this midpoint and the center point, another point here. So you can define the angle of the orientation angle of this lifting lug from the data line. Select the center point here, the same another center point there, and another point at the top to define the orientation of this lifting lug by that way. Now to add the seam lines and the orientation of the nozzles. For example, here we have this anodes, and here we have the intersection or the gap of the welding line. So let's add a center line here for the welding lines of the shells. And from here you can add title like that. So from here, let's add a seam line. On the other side, we have seam line 2 and seam line 4 on that side, and you can add the orientation angle. So if we take a look here, the orientation angle for those was 2,900. So let's add it like that. Let's make it like that, and you can modify the arrow a little bit to make it suits your needs. So like that. And for the other building line, you can make the same thing. So from here, let's add the other building lines. It's seam line 1 and seam line 3. Both of them on 70 degrees. Like that. So you will get seam line, sorry. We have this arrow, so you can move it a little bit like that. Okay, and move the offset that one little bit here, there. Okay, now you have the welding lines. By the same way, you can define the orientation of this one if you would like to make it like that, or if you would like to add title like that to indicate the orientation of this anode at 26 degrees. Okay, so you can add this one like that. For the lifting lugs, you can add nozzle tag to add lifting lugs like that. And here on the same side, you have lifting lug 1. So if you would like to add another balloon for lifting lug 1, you can add it like that by attaching a balloon or select the same one and modify the value like that, which is lifting lug 1 and 3. On the other side, you can do the same. For nozzles, as discussed on the previous one, you can select the balloon and you can add all balloons that you need. Okay, you have platform 2-4, you can add the other platform eclipse on that balloon by the same way. Now we have this vessel drawing, and on the second sheet we have the bill of material. As you can see, the bill of material arrangement not comes on the right place, and you would like to modify the location of this one. So let's first make it start from here, from top to bottom. Here it's start from bottom to top. Okay, so the direction start from 1, 2, 3, from bottom to top, and we need to rearrange this one, the direction. So from here, let's open the table layout, and you can figure that the arrangement start from bottom to top. So let's make it from select top to bottom and make the arrangement start from top to bottom like that, and click on OK. Okay, now if you click OK, for example, you can figure that the arrangement of the bill of material will change like that. Now you can move this bill of material and locate it on the right place here. Okay, now you have this bill of material, and you can split it to different bill of materials or two tables by selecting a row from here and right click and make a table split table to split the table. Okay, so you will get this table as a splitted table. You can move it like that, okay, anywhere, or you can make it by using from the table itself. We need to split the table at cell 57. So from here, let's select 56 row from here and right click and warp table at row. So the table will be warped on the other side like that. Okay, so you can make a warp for table by that way. Now, for example, here, if you would like to increase the width of this row, for example, you can increase it from here like that by changing the column width. So let's make it 80 millimeters and click on OK. Apply. Now we need to increase it a little bit, so 83, for example. Now let's click on OK. Now you can figure that you increased the offset, the width of this column. Let's increase it more. Okay. So by increasing it, you can figure that you have some space here, so you can move the split. So let's remove the split from here. So let's remove the split and make the split start. Let's accept that first to check from where we could split. So from 61, let's select 61 from here and make a split like that. Okay, no, 61, not 62. Let's remove the split from here and make it on the previous one. Okay, and click on OK. Now the split will be like that, and you will get the bill of material on the other side by that way. Okay, so by that way you can move the bill of material and modify the location of this one and control the width of the tables. Okay, now let's come back again to the general arrangement, and now let's add a plan view for this vessel to use it as a key plan and as the north direction and some other blocks for the drawing. To add a key plan, you have two ways. If you would like, you can take a projection from this vessel like that, okay, and move it down here. After that, you can, if you try to move it, for example, it will be vertically aligned for that one. That means you will need to break the alignment, and that option we discussed it on the Autodesk Inventor drawing, the last session of Autodesk Inventor drawing. So if you click on break aligned, you will be able to move this view anywhere like that. So it will be unmovable like that. Okay. And if you double click on it, you can change the scale of this one. So if you make a break for the scale from here, that will give you the ability to change the scale of this view only. So you can make it with a different scale. So let's decrease the scale a little bit. So let's make it to 100, 1 to 100, and click OK. And you can remove the hidden lines. So from here, for example, if you break the link between the style, you can make it with visible lines only, and you can make it shaded. So you will get a view like that. Okay, that's a way to do that. And there is another way, which is importing the visual view to the drawing. And here you have the 3D model of the vessel, so you can import it as a separate base view. So from here, you will select the view like that and move it here, for example, and give it a name as a key and make the that one appears, and you can keep the scale or remove the scale from the title. Now you have this view, and let's make it with a visible lines only, no hidden lines, and click on OK. Now we have this key plan like that, and you can add nozzle tags on that one. If you would like to add nozzle tags on that one, like that. And let's add 10 lines. The other 10 line here. Now let's add a north direction to this key plan. As discussed, you will find in SEG template drawing some samples for that. Some of them for the north direction, you will find two styles here. So if you open the sketch samples, you will find a north direction. So you can select this north direction like that, and you can make a rotate for it because it's blocked. So if you make an or edit the definition of this one, sorry, not edit definition. Edit definition, you will modify the sketch itself. Edit sample, you will get this form, so you can scale it. For example, you would like to minimize the scale a little bit and rotate this one to 45 degrees like that, so you can make it rotated like that, so you can control the scale and the orientation. So you can change those parameters. Let's make it 1 again, and make the orientation value become 0 like that, and click on OK. So that's for the first sample of the north direction. You will find another sample for the north direction, and you can add your standard blocks here by copy and paste. If you have another drawing, some samples, you can take a copy from them and paste them here. Okay. Now we have we add the weld samples here, and we need to add the maximum allowable nozzle load table. As discussed on the previous session, for example, if you have some nozzles with loads, here, for example, for N3, if you would like to add a nozzle load for this nozzle, so from the nozzle form, you will find this button, which is nozzle table. And when you click on this button, you will be able to define the loads on this nozzle like that. When you click done, okay, those nozzles, by the way, if you take a look to the images here, if it's located on the head, you will find the B force, VC, and VL forces, a moment, MT, ML, and MC. So those values for forces and moments, you can define them from this form. based on this drawing. After that, you can click done. Now, if you open the tables and open the nozzle load table, you can figure that N3 now included on the nozzle loads table. So you can define that. Okay. Now, if we come back here, you will find that this table not updated, and we will check how to update those tables inside your drawings if you make a change in the bill of material or on the nozzle table. But now we are discussing the blocks. Okay, so to add a block here for the nozzle load, you will find two blocks here for the nozzle load on shell. So if you get it like that, you will get this detail, and another nozzle load on head. So you can import it like that. By the same way, if you click on edit sample, you can scale it, change the orientation if you would like to make something like that. Okay, now after preparing this one, let's make a detail for nozzle M1A, which including this davit. And after creating it, let's add some items to this nozzle like bolts and hand grip. And those items will not appear on the bill of material of this one because they are created after creating the drawing. So we will discuss how to update the bill of material drawing and numbering for those items. So let's go to M1A from the tree, and let's check it from here and get M1A from the list here, N4, N7, which is in 6, and in 9 here we have M1A assembly. Don't select this one. You will need to select the assembly of the nozzle itself. We create one group called M1A detail. So we will use this group to create the drawing of the manhole, because if you select this one, you will generate a drawing for the nozzle itself, which is a rebad and nozzle neck only. But here we generate a group to collect all items of this nozzle to prepare a separate drawing for them. Now let's select M1A detail and right click, and from here select drawing and create drawing. Now you will be able to define or change the drawing size, select the required views for this nozzle. So let's add elevation and another side, and if you would like to add a top view, no problem. But here, let's select or check first the orientation of this nozzle. So if we, for example, if you take a look for the nozzle from the elevation view, you will get that view as elevation view. So in our case, we need to make that view as the elevation view. So we will need to make the elevation view as the back view to make this view as elevation in your drawing. So from here, let's define the spacing first. Let's make it 3 meters. It's 3 meters. So we will get 3 views: elevation view, side view, and top view. From here, let's make the orientation of the elevation as a back view. So when you change it from here as a back, so you will get this view as elevation. Okay. Now let's come back here and keep those values as they are. Change the scale. Let's make it 1 to 10. After that, we will modify them as they're needed. And from tables, let's add the bill of material table. Let's remove the notes, and from the weld styles, let's remove those and keep the flange, and remove this one. Keep the rebad connection, and no more welding details, and click save. And from tables, let's make it M1A. Okay. And for drawings, let's define the drawing number as that. Okay, and define the revision table as revision 0. And for the approved by, checked by, and prepared by, click on save. Let's add some empty rows on the revision table. And from design data, we will keep everything as it is. We need just one sheet, and click on save. Okay. Now, if you click on create, we will start creating the drawing for this one. But before proceeding with this, let's save the information here. Okay. and that means the information that you decide here will be saved on the drawing file. After that, if we come back to the project from here, select the vessel, and let's make some modifications here to make it reflected to the drawing. Okay, to here, if you take a look, if we take a look for the border, for example, the drawing number, part number, serial number, job number, all of that, we need to make some modifications on those values. So the job number, for example, and the location, manufacturer, serial number, let's change them. So from here, for the project number, let's change the project number, project name. Okay, and the manufacturer. And here we have the manufacturer, the job number, location. Okay, and let's save this. And for the serial number of the vessel, if you come back and select the vessel from here, and from vessel setting, you can modify the serial number of this vessel like that. So after modifying this, if you come back again to the M1A nozzle, and from here, when you click on create drawing and select create drawing, okay, here all data that you modify is already saved. Now when you click on create drawing, you will generate the detailed drawing for this nozzle like that. And here the bill of material for the external items, it will be created here. And finally, here the title block will be updated like the job number and manufacturer and the project name, which is new Cairo project. So here those information will be updated, and you will get the nozzle detail will appear here. Now let's change the location of those views a little bit. So from here, let's select the manhole, and for the location here, so let's change that one a little bit. Let's make it 14 and increase the Y location and make the scale 1 to 8. So we will increase that a little bit, move it on that side. And when you click on create, the scale will be changed like that. Okay, or let's make it a little bit up. Okay, from here, create drawing and change the scale again and increase this one to 33 and make that one like that, and click on create drawing. So we have those three views for the manhole by that way. Now let's add a sheet metal development for the neck of the nozzle and the rebed of this nozzle and that drawing. So let's save this one, and for example, if we open the nozzle neck like that, we will get the nozzle neck part like that as a separate part. Let's open it as a separate part, so you have the neck only like that. Now if you come back to the detailed drawing again and try to add a base view, you will get the nozzle neck as a part here. You will be able to add it as a folded model, or you can add it as a flat pattern bar like that, so you will get the orientation of that one, so you can change the orientation of this plate like that as a sheet metal part. You can define the name of this view as M1A nozzle plate. Okay, like that. Change the scale. Let's make it 1 to so the scale will be, let's increase it a little bit. Let's make it 15. So the scale will be like that. If you would like to add a bended extends or not, or bunch center if you have a bunch, but right now let's accept this. So now you will have the blade, and so you can define the height, the maximum height of that each side by that way, and you can export it in as 1-to-1. The same thing you can do it for the rebed. So if we open the rebed, for example, we have this rebed here. If you come back to the drawing as a manhole detail, and from here, if you add a base view, you will get the nozzle rebed like that. And if you would like to include it as a folded model or a flat pattern model, that's the flat pattern model. And M1A, let's add the name for this one, M1A add and import it at a scale 1:1, so you can add the maximum height of this one and the maximum width. Is the same for the cut to inside, and you can figure that you have a contour on the outside surface and the inside surface. You have two different contours, so you can add a cut for the maximum opening to inside and to the outside, like that. So you have a cut like that. By that way, you can define, or you can export it as the DXF or DWG scale 1:1 to get the accurate dimensions for it. Now let's some important points regarding the balloon of this part. Here we discuss how to add a nozzle balloon, which is reflect the nozzle name from after selecting a balloon. Again, if after selecting a balloon and select nozzle tag number, when you select an item for the first time, you will be able to select if you would like to make it as a structure or parts. So let's select parts only, and from here you will get the name of this balloon. But if you select part tag, the part tag will give you the description or the technical characteristics of this part. For example, here you will find the blade dimensions for this one. For example, here if you take a look, that's the length of the blade. Here, if you check this value with the value here, you have the blade length, and here the blade width of this flat pattern blade, and with the thickness. Appearing to your side?
Yes, now it's appearing.
Okay. Here for the description of or the technical characteristics of this part, it will appear on this balloon. That's in case if you select part tag. For example, for this rebad, if you select the part tag, so you will get the blade information here. And for example, if you select this flange, for example, you will get the information of this one as a technical characteristics of this element. Okay, now let's add some other details for the let's move that a little bit here for that one. Okay, and let's add details for the manhole davit parts. For example, here if we open the assembly of this nozzle, and you would like to add a detail for this davit, so let's open the davit detail as a separate assembly. Here you can figure that the davit detail in a separate assembly appears here with all parts here. For example, if you would like to include this part, get the development of this one in your drawing, you can do that if you come back to the drawing like that and add a base view for this part. You can get a flat pattern for this piece, changes the scale, but we need to add a detail for all the support davit. So from here, let's come back to the detail drawing, and from a base view, let's select here you have the davit view, so you can select the suitable orientation for this one, change the scale M1A davit, for example, and change the scale, let's say 1 to 6, and here you have this davit. You can add another view like that, and now you have those views for the davit. Let's add some dimensions, like adding the center line from here to there. Okay, you have the level, so you can add a sketch here to add the level of the body flange here, and weld this line to this point like that, and another line for the nozzle neck. So let's project this line here, make this point connected to, weld the intermediate point like that, and that's the nozzle. It will be like that. So you can add a definition for parts by the same way. If you add a part tag for this one, select parts legacy, you will add the technical characteristics for each plate like that. And in case if you would like to add a part number, you can add the dimensions. So let's add the center line from here there to modify the or indicate the dimensions from here there, from the facing of this one, the thickness of this one, like that, the offset from the center line to there, the radius of this rod, the diameter of that rod. All of that you can add it on that one. Let's add some part tags. Okay, and for those items by that way. Okay, so you can add dimensions to your part or your model by that way. One more thing we need to discuss it before going to the next step, which is the item number in the bill of material. Here, if you take a look for the flange, for example, the flange item number is 24. Blind flange is 25. So if you select the balloon and from this list select item number in bill of material and try to add a balloon here for the item number in bill of material, like that, so you will get that number. Actually, for the first time you will get it empty unless you make update item number. Okay, so here, as discussed in SEG, if you open the bill of material, SEG will collect the identical items. For example, here for this flange, we have 4 identical flanges. They have the same description. They have the same technical characteristics. Okay, the same size, weld neck, wrist face class, the same schedule. They have the same material and they have the same weight. Those flanges, they are located on nozzle N1, okay, flange 1, and the nozzle N1, flange 1 and 2, and you have here another flanges also on N2. Okay, so you have 4 identical flanges with the same size and same information. Now SEG make a sorting for items based on the identical items, okay, in the material, weight, and the technical characteristics, and collect them and give them the same item number. Okay, to reflect this item number to Autodesk Inventor parts, you will need to make one important point, which is from the assembly tab, you will need to click on update item number to update all item numbers in your model. Okay, now let's let's add some bolts here. We will add some stud bolts for this manhole, and let's add one more hand grips, top hand grips for this manhole. Okay, so let's come back to SEG3, and from here let's select M1 detail and select the blind flange from here, and from elements let's add a stud bolt. So from here let's add M1 a stud. Okay, and click on OK. Now we have a stud bolts generated on the blind. By selecting it, you will be able to select the size. So let's select the size of the stud bolt, define the length from here, and for the knot spacing, you can add the knot spacing, which is the distance between those surfaces. So it's 100.7, like that, and click on Save. Now when you click on Start Assembly, the bolts will be generated as a separate parts. Now you will get that on the nozzle assembly detail. So if we open this nozzle assembly, here it will be included in the assembly of the nozzle. So that means when you open the detailed drawing of this nozzle, automatically you will find those bolts are reflected to the assembly here. But right now it's not included on the bill of material. Okay, now we need to update the bill of material, but first let's add a hand grip for this nozzle. So from here, let's close this nozzle and come back to SEG and select the blind flange, and from elements let's add M1A grip, and let's modify the hand grip, select the suitable type, keep the values here and keep the orientation. We have 2 hand grips, and click on save and check the orientation if it's okay or not. If it's not, we will change the orientation of hand grip to suit the David location. Now, as you can see, the orientation of the hand grip is okay. No need to change the orientation of the hand grip. So if we come back to the drawing here, you will find the hand grip location now, or the hand grips located again on the drawing. So you can define the offset from here to there. Let's add a center line for this nozzle. We have a center line here, so you can define the offset from here to there. The same for the other hand grip. And if you would like to add the balloon as a part tag, you can add it like that for this rod. And from here, let's update the bill of material of this one. Update the bill of material here and reflect the balloons. For example, if we add a balloon of the part number of this bolt, you will get it empty. The same for the nut, for example, and here for the stud bolt. So now let's update the item number of those balloons after creating the bill of material, and update this bill of material to include. Now let's take a look to the bill of material here. Okay, we have item 24 here, and here's the sliding blade. And if we open the bill of material table and get down here, okay, we will get the bolts and the nuts for this manhole. Now you have the number bolts and the nuts for this manhole. They appear here with the material and weight. To reflect them, we need to update the drawing. So how to update the drawing and update the bill of material in this drawing? It's very important to know that you will need to open the drawing form again, and from tables, okay, we need to update the it's a nozzle M1B, sorry, let's select M1A, and from here let's open the drawing and select create drawing, and from tables tab you will need to update the bill of material table. In that case, you will need to select this checkbox. This checkbox will give you the ability to update the selected tables here. This checkbox will make a loop on the selected tables and update the tables here during creation. Let's check that after selecting this checkbox. Let's create drawing and check what will happen here. You will find the bill of material here will be updated. It will be removed, as you can see. And now the new bill of material will be filled and updated again. Now if we move it a little bit up here, because we have some cells increased, you can figure that we have here a stud bolts and the nuts here, and you will get the hand grip. Here we have the hand grip, and the numbering of items changed. Okay, so now you have those items, and you can figure that the external items will appear here, so you can remove those external items. So select those external items from here to there, okay, by clicking on shift those items and make them invisible, okay, and click on OK. Now you have those items exported here for that one, and let's click on save. Now let's update the balloon of the item number, and this process may take around let's say 10 minutes to update all of those items. We have more than, I think, 100 items here. We have 276 items, and SEG will reflect the item number here. For example, here for this seamless pipe here, SEG will reflect the item number to the main part in Autodesk Inventor. The same for the nuts and stud bolts. For example, here for the stud bolts number, it's 92, and for nuts it's 91. So SEG will send this number to all nuts on this. So from here, let's select assembly and click on update item number. And as mentioned, this process will, as you can see, it will send the item numbers to the Autodesk Inventor parts and assemblies. During this process, we could make a discussion. If you have any questions, I could make it clear after updating the item number. Okay, any questions?
I have just one small query related with this document number. I mean, the document, the part numbering. Can we see the drawing of this manhole? That is
okay. We still wait the updating item number. As mentioned, it will take between 10 minutes. So we will not deal with Autodesk Inventor or SEG until updating.
Okay, no problem.
Your question. Okay.
My query is, like, each time you have added any part, what it's doing is that it's updating all the document, all the part numbers. It shouldn't it be like adding the part to the last number?
No, because SEG used the grouping system, which is mean that let's open drawing like this. And for example, we have a formed head. So it takes a group number 1, for example. Okay, so if you have more than one head, for example, if you have 3 or 4 heads, you have 2 boots, for example, and right and left head. So the grouping system will start with the formed heads. So all formed heads will be on the top. Okay, so if you increase a part like formed head during your project, all below parts number will change. Okay, for the formed blades, rolled blades, it takes group number 2, or for roof and bottom. Okay, so it takes group number 2. That means if you increase any sheet metal or shell course during your project, all below parts number will change. So that means if you create a new part, it will be arranged based on the group form or group number of this part. So we will start with formed heads. After that, rolled blades. After that, the pipes, flanges, fittings. So after that, at the end, you will find the bolts, stud bolts, davits, or platform clips. So all of those items will come down on the list. So they will not sorting. If you add a new item, it will appear at below, because SEG make a sorting for that based on the group number.
Okay, got it. But Mr. Ahmed, I think we have to do something on this, because while a project is going on, maybe in the mid of the project, by any reason, a new part is added. So this new part shall not disturb the part numbering of other parts which are maybe in the process of cutting, rolling, or any other any other process. So the part numbers shall not be disturbed. So I mean, I think we had discussed this before also.
Look at this. Here in the bill of material itself, the item number will be typical with the balun of this part. So if it's changed, it will be changed on 2 places: the bill of material and the balun of the item number. So that means no change for the description of the technical characteristics of this part. It's just the arrangement of this part inside the bill of material list. But it will take, as I will show you now after updating the item number of this vessel. I will show you that for example, if we take a look for the updated items like hand grip or the bolts, they will get the same value on the bill of material. So it's not a change. It's the same. Just I hope my point is clear. I get your point, but here in SEG we use another technique for arranging the items. Okay. So the same number will be reflected on the drawing. If you have new items during the project, they will get the correct item number on the bill of material. They will not get another number. They will get the same number on the bill of material.
Yeah, I got your point that the same number will be indicated on the bill of material and also in the balloons.
Yes, and I am getting your point too. But here with the SEG using this technique, which is described now by grouping the elements, depends on the form of the material, like formed blades or forged blades or fittings, or like that. So we are using this technique to make sorting for items in the bill of material. Because sometimes if we thinking by using your method, which is any new part will come below, so you will not be able to, let's say, after creating your project on the next revision, you have some deleted items, like some nozzles are deleted, change some platform supports or something like that. So those are items will not be included. That means you will need to include deleted items on the list. Okay, and actually in the correct place, they will not be. You have an empty cells taking a number on your bill of material. You get my point?
Yes, I
so
got your point.
SEG will sort the items based on the mentioned grouping system in SEG.
Okay, Mr. Ahmed, I think we will have to discuss more on this because really it will be required. Like, okay, maybe first revision or second revision, okay, changing the numbers will not affect us. But once we have issued for construction, so what we do, we take the bill of material in and put this in our ERP. And this ERP, and then the process starts that the part goes to CNC, and maybe once the part is cut, the QC, the reports, it's marked like the part is cut. Okay, and now in the third or fourth revision we add a new part. So if this new part is changing the numbers of all the parts, so it will disturb our system, and it cannot, I mean, our system cannot absorb this new change. So
in your case, if we delete some items, what will take place in your bill of material by using your logic?
yeah,
If we delete some items,
it will be deleted as deleted only.
It will appear on the bill of material as a deleted item.
Deleted item.
So we need to understand the logic that you are using to use the same logic for arranging. Because in a certain point on this project, we need to fix the current bill of material, okay, and keep SEG, store it in a certain format. After that, if we delete anything, it will be deleted. If we add anything, it will be added to below, not on the middle.
Yes.
So we need to understand this technique or this logic in detail from your side to upgrade something like that.
Yes.
Here we SEG is still updating this. So any questions during the update?
Mr. Ahmed, as we had discussed on this tank training day, we have some queries listed down. It's a lot of queries. I will share after this training session to Fawzan, and also I will be sharing you the sample drawing of a typical site tank. Okay, so you can see what parts, and it will be like typical to any site project. Now we have a new project in which we want to induct SEG as a 3D modeling and detail drawing software. So we will be like having too many to and fro. I mean, we will be needing to and fro communication with you to solve the issues. Like if we are able to clear one project, and then class, it will be very smooth. But first project, we will have some obstacles.
Sure, inshallah.
Mr. Ahmed, you are on mute.
Sorry, very sorry for that. Because what's making it mute? Okay, no problem. I'm sorry. I'm discussed here the reflection of the balun on of the item number after stopping the updating item number. We discuss the reflection of the balun item number here and make it typical to the bill of material. After that, I would like to describe the how to modify the weld style for nozzles and how to add values here and get a weld style here and reflect that with a weld style here and make it appears on the drawing area. So for the first step, let's select the nozzle from the tree for nozzle N1, for example. And from here, open the set weld button to get this form. And from this form, you can select the drawing, for the weld groove, make it a single groove or double groove. So for this case, for example, make it single V. And from here, you can add the clad. So you can select the detail for the clad. And now you will be able to define the fillet weld for those values. So from here, let's 14 and 10, for example, for value C from internal. And when you click on save, those values will reflect it to nozzle table. So for N1, for example, you can figure that we change the weld style, and for the values of for A, B, and C, they will appear here on the drawing. Let's check another nozzle, for example. Let's select N5, for example, and open the weld set. And for N5, let's define those values as 12, 10, and 8. Okay, and 8. And click on save. Okay, and let's add a nozzle load for this nozzle by selecting this one. And let's add a nozzle from nozzle load like that, and click on save. Now, when you open the nozzle table and get nozzle N5, here we have nozzle N5, you can figure that the weld style changed and the values of the weld will reflect it here. And for the nozzle load, if we open the nozzle load table, you can figure that the nozzle load will, this nozzle will appear on the nozzle load. Now, to reflect the updating on the nozzle table and the nozzle load table on your drawing, let's check how we can make that. So let's select the vessel node from the tree. After that, select drawing and click on create drawing. After selecting this, when you comes to the table and annotations, you will need to select this checkbox, which is update tables automatically. But now, if you take a look to the selected table, that means when you select this checkbox, you will update the bill of material, design data, nozzle table, maximum allowable nozzle load, nodes, client document list, and the vessel document list. So you will make a loop for all selected tables here. But in your case, you don't need to update all of that. Just you will need to update nozzle load and the nozzle table. So let's remove all the checkboxes here, okay, and select keep those values selected. Okay. In case if you have a new welding details you would like to add, for example, you would like to add this detail and that detail, for example, okay, and for elbow detail, let's add an elbow detail and remove this connection. You have an elbow detail and two different thicknesses connected to it. You would like to include those details in your drawing. If we take a look to the current one, we haven't here those details. So we need to increase those welding details on your drawing. So after adding them, click on save. And now when you select update welding details, that means anytime you will generate a drawing, you will make a loop for selected tables to update them, and you will make a loop on the welding details to update them. Okay, so now let's click on create drawing to update nozzle table and the maximum allowable nozzle table, and let's check what will happen. Here, you will figure that the nozzle table here will be updated. As you can see, it will be deleted and refilled again with the correct values. Okay, like that. And after that, the maximum allowable nozzle load table will be updated. Finally, the welding styles, so the welding styles will be removed, and the new welding styles that selected will be updated. Okay, now as you can see, after updating the job number and manufacturer, all of those values reflected to your border after updating it. Now let's, if you would like to increase the width of this cell a little bit, you can make it like that and move this table a little bit up, move those blocks here. As you can see, the maximum allowable nozzle load table now updated. And if you take a look here, you will find this nozzle weld style appears and that nozzle here. So the table here now updated. Okay, now let's add the weld style for the nozzles on your drawing, or add the weld styles for the weld lines here. For example, if we open the samples and the sketches, you will find here a folder for weld details. And you can figure that you have some weld details arranged from 1 up to 14. You can add more if you would like. So let's give a name for this weld detail as W1, and this one as W2, W3. Okay, and for this one, it's W4, W5. Okay, so we have those details. Finally, let's move the key plan up down a little bit like that. We have the last one, W5, so we have W6 for this one, and W7 for that one. Now, we have this connection for the longitudinal welding lines, which takes W1 tag. So from here, if you would like to add a tag number, you can add W1 and make it with a lead text. And from here, let's select the weld lines, like that line, for example. So that line will be related to W1 detail. So like that, you can add a weld detail. So that means here that welding line will be related to this weld style. For the sorry, that's for the longitudinal welding lines. Sorry. So let's select them like that and make them W2. So from here, let's edit. So edit the sample. So from edit sample and select W2 instead of W1. The same we will make it here, W2. And that one. So edit sample, not edit definition. Edit definition will give you an access to edit the block itself. Like if you select edit definition, you will be able to modify the block itself, like edit block. Okay, so from here, let's make it edit sample and select W2. For the circumference welding lines, we have detail W1. So let's select this one, and here we have W1 like that. And let's add another weld detail for the circumference welding lines like that. And finally, that one. Okay. Now let's add some other welding details for, let's say, for the nozzles. Here we have nozzle N7A, which is nozzles with internal projection and reinforced pad. So from here, let's select that one, and from that folder, which is nozzle weld detail, let's select N7A. So from here, let's select NW7A, which is that one, and like that. And from here, you can select this detail to indicate that this nozzle weld style will be according to NW7A. So if you take a look to the weld style here, so the weld sample will be NW7A, and the dimension A, B, and C, those are the values. So if you take a look to that one, so dimension A, which is the fillet weld between nozzle and rebad, will take the value E. The fillet weld between rebad and shell will take value B, and the fillet weld from inside with nozzle and the shell or the parent, it will be like that. So to define the gap value, which is G and N, you can define them on the general notes, or you can modify it like that. So from text, you can make it 4 millimeters plus or a -1. So you, for example, so you can make it like that and make a copy properties to update this here, and the same you can do it on those sides. By that way, if you have any gap like this, you can modify it like that. Okay, so by using copy properties, you can make the copy your properties for a modified dimension to another dimensions by that way. Now we have the welding styles to identify the nozzles. We create a detailed drawing for the manhole, and now let's create a detailed drawing for saddle. After that, we will discuss some points related to the storage tank. We will open all the project of the storage tank and prepare a drawing for the general arrangement drawing for the tank, and discuss some of the detailed drawings. Okay, now we have we will need to make a detail for the second saddle, which is the sliding saddle. So from here, let's select the saddle and the saddle group, which is second saddle. And from here, let's create a drawing. And from create drawing, let's select the drawing size as A2. And from here, let's add 2 views for the saddle. And let's come back to the 3D model and open the assembly itself to check which elevation we would like to present. So from here, we would like to present the front view as the elevation view. Okay, so here we will make the front view as the elevation view, or make the back view as the elevation view. It's up to you, but we will make it here as a front view. So let's select the front view. Let's define the spacing between views here. And from here, let's select the front. Okay, so to make the front view as the elevation view. And from here, let's change the scale. Let's make it 50 and location make it 30. Make the scale 114. And for the tables, let's remove the notes, add the bill of material table. And for the weld styles, let's remove those details and keep the wear plate weld with the shell, and the if you have a whip like that. So let's add this detail. Okay, and here no other details, and click on save. Now, if you would like to add some dimensions to this drawing as a quick dimensions adding, you can do that by using the dimension tab checkbox. You can add some dimensions automatically in SEG, but we don't recommend using this option because you will get a huge number of dimensions in your drawing, and you will need the time to delete not required dimensions. But let's try it to show you that option. So from here, let's select dimensions and select 2-point distance. So SEG will detect the lines and add dimensions for the 2-point distances. And from here, let's add the detail name for this drawing as paddle. Okay. And from here, let's add a document number like that. And from here, let's add a revision number like revision 0 for issued for review. Okay, and the same as discussed on the previous drawings. Let's add some empty rows, and for here we will make a single sheet as discussed. So let's click save on that one. And here, if you would like to make sub details, another sheets for, let's say, for the base blade, for the let's say for the web blade, the ribs, anything included in that one. So if you open this assembly, for example, you will find this saddle included the base plate, web, different ribs, wear plate, and stiffening ring. So if you would like to make a detail for that, for example, if you make a scan component, you will get those items here. So you can make a lift, select that. For example, if you would like to add a detail for the some of those items, you can do that by selecting it and add dimensions for it. But right now, we will not select anything and start creating the drawing directly. So we will get a detailed drawing like that, and we will have a side view with dimensions, and elevation view with dimensions, and a side view here with some dimensions. As discussed, you will get a huge number of dimensions. So if you would like to don't include something like that, you can remove the option of automated dimension, because you will need a time to remove not required dimensions. So let's come back to SEG, and from here let's remove or delete this drawing. So from here delete this drawing and recreate it again, but in that time we will remove the option of dimensions. So from here let's remove this option, okay, and click on create drawing. So we will create this drawing again from scratch. So we will get that view. Okay, now we would like to make a group view. We discussed the crop option, which is giving you ability to cut this view. So from here, let's select group option, and from here, let's select this area. Okay, now you make a cut on that view like that, and you can modify the group cut if you open this sketch like that, and you can select a defined area. The same thing, you can do it on the second view. You can make a group view like that, so you can make a cut on that view by that same way. Okay, now let's add some dimensions for this saddle. So from here, let's add a base from the height from here to there, the base plate height. Okay, the bottom plate, which is the shim's plate below here, you can add the length of this one, the spacing between ribs. So let's add some center lines here for the ribs like that. Okay, and let's add center lines. Let's add the center line for this one. So we have the center line here. Now let's add the spacing from that center line from here to there, and the center line on that side like that. Now let's come to the second view and add some dimensions. We have here that the bottom plate. Let's add the thickness on that view. Let's move the thickness a little bit up. Let's add another dimension here for this plate. And let's add the inside diameter like that, or you can make it as a radius like that. You can add the height of the rib on the drawing, so the height will appear like that. You can add the thicknesses. You can add a weld detail. So from here, let's select from the weld samples. You can select the weld like that and add a weld sample like that. So 12, okay, and make it in the two sides. Make it typical. Okay, and make a detail here for this cut. So if we go to place view, as all of those options we discussed them on the last session of Autodesk Inventor training. So if you would like to make a detailed view with a contour line like that, you can take a copy from that one and define the offset from here. Let's make the offset from here to there, define the radius of this one, so you can add dimensions on your drawing and make sub details like that. Let's add some other dimensions, like here we have this one. Okay, radius, the stiffening ring. If you would like to add thickness like that, okay, and the saddle width. So let's this one, move this one a little bit up like that. Okay, and here the distance from here to there, the same on the other side, 25 on that side and another 25 on that side. So in minutes you can complete your drawing. Now we want to make a section or add a detail for the base plate. Okay, now for example, if you try to make a section here like that, you can get a detail for the saddle with ribs. So it will be like that. So you can modify the values by that way, or you can make a separate detail for the base plate. So if we go back here and open the assembly of this saddle, we can open the base plate only. So from the saddle assembly here, let's open the base plate. So that's the base plate. So if you open it here on a separate drawing, you can include it as a base view here. So let's take a look from the top view, and you can move it here and change the location. So let's make it as a base. changes the scale as 1:14, like that, and click save. Now you have the space plate detail. So let's add some center lines here for holes, like that. And now let's add that dimension, and from the center line, let's add dimensions like that. And for the total length, we have the spacing from here to there. Let's make it aligned, and by the same way you can add the spacing from here to there, like that. Is well spacing. And to make a detail for this slot hole, you can make a detail by that way. For example, let's make it so you can move it a little bit out here and increase the scale 1:4, for example. So you will get this detail like that. You can move it and decrease this detail a little bit like that. Okay, and move it to the center. Now you will be able to add dimensions for this one. Okay, like adding the slot is. So from here to there, we have the total length of this one, and here you have the slot hole width, like that. Okay. By the way, if you would like to remove this text a little bit down here, if you select it, it will move around the circle. But for example, if you would like to move it out, you can select it, and from here, select leader. Now you can move it as a leader text outside the detail by that way. So you can make a detail sketch or a detail label like that by that way. Now let's add some balloons here. So from balloon, let's select item number in bill of material, which will reflect the item number here to the bill of material. So from here, let's select this one and item number in bill of material. So when we select this one and select parts only, so in that case, we will reflect the item number on the bill of material. Here we have that's the base plate, and here's the shims plate, sorry, or let's select it again, select that line. Okay, so as you can see, this item not included in SEG item number or library, so it will not take a number. You will need to add this number manually. The same thing will be for the grounding lug. And if you open the grounding lug, for example, let's come back to the assembly of the nozzle, and let's add this grounding lug here. If you open it, because we created it manually, here you will find a balloon for the part number. And if you check the SEG bill of material here, let's open the bill of material of SEG. Here we generate a grounding lug manually, and it takes 99 number. So when you come back to disk inventor, you can reflect this value here. And when you open the drawing, which is that drawing, the balloon number here will be updated. The same for the sliding blade here. It takes number 101. So if we open this part on, let's close the grounding lug and open the form of this item, which is a base plate or shims plate from here, and open the form of this one, you can find here a value for part number. So let's make it 101, and this value will be reflected here on the title as a property, summary property for the title. So you can modify it like that. If you come back to the drawing, here we have the drawing, you can figure that the balloon number will be reflected here, and which is the should be the sliding blade number. Here this bill of material should be updated based on the detail of the which indicated on SEG bill of material. Now, after creating this drawing, let's discuss how to export those drawings in different formats, or how to export the 3D model in different formats. Okay, you can do that from SEG itself. From here, for example, if you would like to export the 3D model on another extension, you will select the vessel node from the tree, and from here you will find export to. Okay, and you will get this form. And down here you will find some different extensions like the DWG AutoCAD extension, PDF extension, STEP extension, STL extension. Those extensions, you can use them if you would like to export the 3D model to another CAD software like CATIA or Pro Engineer or SolidWorks, so you can export the 3D model to many different extensions. Now let's export it as an AutoCAD DWG file, okay, and try to open it as a 3D. Now we will export the 3D model as a 3D model in AutoCAD. Now SEG will make this process, which is exporting the 3D model. It may take a minute. Now it's, I think it's okay, it's done. Okay, and SEG import you that exporting done successfully. So let's open the folder of the project. So from here, we will find, sorry, where is the assembly? Which is day 7. Yes, here we have the sand filter DWG drawing. So let's open it by using AutoCAD. Here we have this one, and let's change the shading. Okay, now we have this model, so let's work it a little bit. Now you have the 3D model of this vessel on over AutoCAD, so let's remove it a little bit like that. As you can see, you can will get a 3D model in different extensions by using the exporting tool of the 3D model. Now let's export the 3D model in PDF extension. So from here, 3D PDF. So from Autodesk Inventor itself, you will get export. And from here, you will find 3D PDF. But before that, we would like to discuss the presentation views. So from representations, let's open this. You will find here views. So let's check the default view. So here, that's the default view of the vessel. So let's make this view as the default view. And let's add another views like front view. So from here, let's add new view like left view. Left only, okay. So the left view will be from here. Okay. And let's add another view like front view. And let's name this one as front. Okay, and it will be like that. Okay, and that one will be top. Go to top view, and now that will be the top view. Okay, now if we check the default view, here we will get that one. The left view will be that one. The front view will be that one, and the top view will be that one. Now, if you would like to export the 3D model, those views will be exported during the exporting of this one. So from here, for example, if you would like to define the clash between items, for example, and send that as a comment for your client, let's add a new view here and name it as N1 clash, N1 and seam line 1, for example, clash. Okay, so you will make a view like that, and so this view will be closed to here. So the view will be closed to this one. So if you select the default view again and come back to another view, so the default view will be near to the area that you would like to identify. Now, when you try to export this to a 3D PDF, so from here, let's select create 3D PDF. You can select the required views that you would like to export. Here we select default, left, front to top, and the nozzle N1 and SIM1 clash. For example, if you would like to export some other information, like who is designing this one, the company, so you will find some informations here. You can fill it from the setting of this part. So if you open the title block, for example, you will find here the title, subject, manager, company. So if you would like to fill values here and make it exported during the drawing or the 3D PDF exporting, you can include it from here. From here, you can select the quality of the visualization view, and I recommend selecting low quality because the size of this part of the PDF will be with a small size and with good representation. No issues with the presentation. So let's select the low quality, and from here click on publish, and already we have another one located on the folder, which is the last one. You can delete it or accept from here directory to delete the old one. Now, as you can see, the disk inventor will start supporting the 3D model of this vessel as a 3D PDF. Okay. Okay, now the 3D PDF on the final step to create. Now we have the 3D model in PDF, so you can rotate the view and check if you already we make a section, so that's the default view. If you select the left view, you will get the exported views as they're discussed, and here for like that we have a view for that one, and you can add a 3D comment like a clash, for example, here. So you can add a 3D comment here and save this file. Like that. So when you send this comment for your client, he will be able to get this one. So let's use this. Okay, move to another views. Now you have this clash here, top view, front view, and he can rotate the 3D model. And if you would like to measure, for example, if you would like to measure things, so it's a little bit close like that. If you would like to measure something, so we could, by using the measurement tool, he could measure the distances, measure the thicknesses. So from here, this point to that point, let's make close like that. If you would like to measure from this point to that point, okay. So you have many options inside the 3D model. Okay, you can make a rotate by selecting the left button on your mouse, so you can make a rotate. Making a band by using both of right click and left click on the same time, so you can make a band by right click and left click on the same time, so you can make a band. make the ruler to make zoom in or zoom out. You can change the light, you can change the perspective view or the shading of this part like that. Okay, you can change the shading, you can change the transparency of the part. Okay, make it perspective view or orthogonal view. So you have many options to make on the 3D PDF. Okay, now let's discuss another feature, how to export the drawings to different extensions. Here we have a drawing already created on SEG, and we would like to export it as a DWG, for example. Here, if you select the vessel node from the tree and right click here, you will find on the drawing list, you have the ability to export the drawing directly from here. Or if, for example, if this drawing is, you are closing it, so let's save this one and close it. Now the GA is closed. You can open it from here. So from select the visual node, and from drawing you can open the drawing. So it will be opened on Autodesk Inventor. So it will appear like that, and you can export it from here and select export drawing to. Now you will get this form, and from this form you will find some different extensions. One of them is the AutoCAD drawing DWG or PDF. For example, let's check the PDF extension and give this drawing a name like and locate it on the project location. It's day 7, and from here let's generate this one. So SEG will export this drawing in DWG format. As you can see here on the status bar, this green bar appear here, making the process of exporting of this drawing. Now the PDF is now exported, and you will receive this message that export drawing successfully completed. If you open the project folder, you will find here a PDF for the general arrangement drawing as a PDF. You have the 2 sheets here of the drawing. One of the first sheet 1 of 2, which is including the views of the vessel, and the second one, which include the bill of material. Now let's try to export this drawing in DWG. So by selecting this, and from drawings, let's export drawing to and select AutoCAD DWG. Select the project location, day 7, and make it as a DWG. Now this drawing will be exported in DWG format. Okay, after exporting this drawing, let's take a look to the project path. If you take a look here, you will find a general arrangement drawing sheet 2 and sheet 1 here. So if we open this one on AutoCAD, we will get this drawing exported in DWG format like that. Get a good representation like that. So you will get all information in a separate drawing. Okay, the same for the bill of material drawing. You will get the bill of material like that. Now let's discuss how to export the bill of material in Excel format. So from here, if we open the bill of material, you will find here a button to export the bill of material in XLSX format. So let's click on that one. From here, let's select the project location. Okay, and let's delete this one. And now let's create the bill of material. Okay, and let's click on save. Okay, when you click on save, SEG will export this bill of material. Here we have an Excel sheet called bill of material. If you open it, you will get an exported bill of material here, which includes the item number. So let's adjust this to be on the middle. Here you have the quantity here and the description of items, technical characteristics of the items. So you will get a list like that, which include all items in your project. And by the way, you will find a list here, which I identify the part name, which is related to that one. Okay, like that. So for the first item, which is that one, it's related to right head. The second one, it's related to the left head here. So let's decrease this one a little bit like that and come back here. Let's make this one, let's hide this column. So from here, for this one, you can figure that it's for the right head. The second one for the left head, that can one, can two. So here you will find the name in the thing. Okay, so this item name will be located on. Now let's close this Excel sheet like that. And let's discuss one more thing here regarding the notes. You can add your notes as a text. So from here, for example, if you open, select a text, and from here, for example, let's add notes like that. And let's open this Excel sheet, which includes some general notes. And let's take a copy for those notes, for example, and come back here and make. So you will get notes like that. So let's remove number 1 and here number 2, make enter, and for number 3, for example. So let's add those notes here, number 5. So we need to check number 4. Here we have this number 4. Okay, now let's delete some of those. So from here, let's take those and delete, and let's keep those as general notes. And from here, you can give them numbering by adding ABC numbering or add dots like that. So you have the ability to define that one, give that one another size for the text. So by that way, you can add a notes as a general notes by that way, by adding a text and define the width of that one. And if you would like to add a border or let's say a contour for this one, so let's check how to make that. So from here, and that changes a letter from caps lock, and here for okay, you can add, by the way, sorry, you can add some parameters value like physical properties or custom properties to the drone, something like that. If you would like to include it here, you can add it from during importing this text. You can add, like in Word, you can change the spacing between lines, make it double or half. You can deal with the texts here by the same way, changing the scale offset or making a stretch for the sketch or not. So from here, click on OK to update this form like that. So that's another way to add notes instead of using the notes from SEG directly. Okay, now let's, if you have any questions for this project, we could discuss it before going to the storage tank for the remaining 30 minutes. Any questions before moving to another project? Hello, any questions?
Yeah, no questions from my side.
Okay, so let's move to the other project. So from here, let's open another project, which is a storage tank project. And from here, let's open day 6 and open the storage tanks model. Now SEG will close the current project and save all information. After that, open the new one here. As you can see, all files now closed. And now we have the storage tank model. Here we have the 3D model of the storage tank. It's like that. That's what we created on the storage tank session. Now let's prepare the general arrangement drawing as discussed. Here, if you would like to modify the project information, which will be located on the title block, so you can modify it from here. For the vessel setting, you can modify the service of the vessel, the serial number of the vessel, so you can fill those data like that. Now let's create the equipment drawing. So from by selecting the vessel node from the tree, you can select drawings and create a drawing from here. Select the drawing size. After that, select the required views. We need an elevation view, and this elevation view you can decide from which view you would like to take a look. Let's make it from back view, because if we make the back view and take another view, here the arrangement of nozzles start from 0, 90 degree on the right hand side. So the back view will be a good view for presentation. Okay, so let's come back here and select a single view. After that, we will add another view manually. And from here, let's select the back view, make all lines hidden with hidden lines, change the location of this tank. So from here, let's change the X and Y direction and change the scale to 1 to 50, for example, so that we will decide which scale we will need. Let's add a bill of material, design data, and nozzle table. And for welding styles, you can select the required welding styles that you would like to export. For example, here let's come back here and select the detail for backing strip. If you have a backing strip, here only on the side weld. If you have an overlap, to decide the overlap, and flange to nozzle neck weld. For the bottom plate with the annular plate. So you can select the required welding details, like that's the annular plate with the other plates. And if you have a compression ring or something like that, or another stiffening ring, you can select the required welding details. After that, click on Save. And from tables, let's name this one as arrangement drawing, give it a document number. And from here, edit the revision table. And fill those data. After that, you can update that. And from here, if you would like to export, as mentioned, if you would like to export the bill of material on a separate drawing, you can do that in case of you have another sheets. Now let's select Save. And when you click on Create, you will use the same reference border. In case if you would like to change the border, you can do that by defining a new border for the new project, or a reference drawing, sorry. Now the bill of material list will be filled and created and take the correct place on the drawing. As mentioned, based on the parameters that you defined for the border height, border width, and title block height, title block width, all of that. So for the previous project, if you think about the time consumed to generate the 3D model and the time consumed to generate the drawings, you can figure that in, let's say, between 6 and 8 hours, we generate a complete and a detailed 3D model for the equipment and prepare general arrangement drawing and detailed drawings for this vessel. And during that, we are discussing some points like the type of saddles, the type of lifting lugs, all of that. So if you have a good experience in using SEG, you may take less than that to create the 3D model and detailed drawings for your equipment. Let's say, for example, you may take between 4 and 5 hours to generate the 3D model and the detailed drawings for this equipment. And actually, all of us knows that in actual case, by using the traditional way, which is AutoCAD, you may take minimum for the previous vessel, minimum 4 days to generate working days for a person to make that. But here, in that case, you may take a half day or 6 hours to generate the same. And with a professional producing, you have a 3D model. You can present your equipment with some high representations, not like in AutoCAD. And any issues like clashes or something like that, you can detect it easily by using the visual inspection for your model, as discussed on the previous sessions. Automatically, if you take a look here, you can detect if you have any rebads near to welding line. So anytime, for example, you would like to measure the distance from here to this welding line, you will get this value. That means you may need to locate this welding line on a different orientation, for example, to avoid this close area for the welding. For that one here, you have a close space between this surface and that welding line. So you may need to change that to avoid clashes. Okay, so now let's come back again to the drawing here, and let's add another view. So from here you can add another perspective, top view like that. Okay, and you can change the scale and the location of this view. So let's break the link between those views from aligned and break. Okay, and you can move this view a little bit. Sorry. So you can move this view a little bit here, and we can move the elevation view to the right hand side and top a little bit. So let's back here, and from view drawing, let's select the orientation view and change this one like that and make it 40, and change the scale a little bit to 60, and click on create drawing. So the view location will be changed like that, and you will get an elevation view. And here you have the top view. If you would like to break the link between the scale to change the scale of the top or make it without hidden lines, you can do that. So by different ways, you can prepare your drawing as you decide. Now let's define the course height for each one. So from here, let's add the height of courses, shell courses, like that. For that course, and for the last one, you can define it like that. The inside diameter of the tank. So we have here the inside diameter. Okay, so let's define it as ID. So from here, let's add a text, and here let's add like that. So that's the ID, and from here you can add a thickness for each one. So you can add a thickness for the first course like that, thickness for the second course, and you can move that right here and add a text like thickness. And if you take a copy from that one and copy properties to here, you will get that notification like that. Okay, now let's prepare a drawing for the bottom plates. Okay, by the same way you can add, as mentioned, add balloons for nozzles. For example, here for the nozzle tag, you can add a tag for this clean outdoor. For example, let's select a clean outdoor. So when you select it and select parts, you will get the name of this one. And for this nozzle, for example, if we select it, you will get M1. You can add a location by defining the data line. So here we have that data line. So after defining it, for example, let's define the level location for the spiral stair start point. So from here, for example, let's click on continue and move it a little bit here and hide the origin indicator. So that's the level of the bottom of the platform, and from here you can define the height of the first platform, the height of the second platform. Here we have that the top of grating, so it will appear like that. Okay, and to make a sheet metal or development for all of the shell. Okay, here for the tank, you can make a shell development for all of the shell, but without the attachments. Here we make an approach for that. For example, here if you open the assembly button, you will get here an option for shell development. If we open it, you will get a sketch for the arranged plates of this tank. Like that, you have can 1, and in inside can 1 you have part 1, part 2, part 3. Inside can 4, for example, you will find those plates. So you will get the arrangement of plates like that on that sketch. And when you click on create flat pattern, that will give you the ability to create the 3D model of the plate development of plates arranged with each other, and that's approach by CAD Solutions. Now the first course will be generated like that. Okay, and here the top can. Here that's the top course of plates. As you can see, if you take a look for the first row, you will find that you have two plates with different thicknesses because they are taking a different color, darker color, darker than the other colors on the same row. That means those plates with a different thicknesses, and easily you can detect that from the 3D view. Finally, you will get the orientation of the welding lines on the 3D model. Here you will have the 0 degree, so the welding line here located at 0 degree. Here you have a 90 degree. So let's add this assembly inside your drawing. So from here, let's add a new sheet, as we learned that you can add a new sheet. So inside this new sheet, you can add another view. So we have this view. You can increase this scale a little bit. We will wait a minute until Azan finish. Thank you. Okay, now after creating this this view, for example, let's increase the scale a little bit and name it as sheet metal shell. Okay, we have this shell development, so you can define the spacing from here to there, define the length of the plates after forming. So let's align those dimensions, move them a little bit down here. So you can add the length of plates by that way, the height of plates like that. Okay, you can make a section, a longitudinal section. So if we take a section, for example, here, and make it outside there and break the view. So let's break the view for this one to move this one a little bit down here. And from this view, let's remove the talon of the angles. Let's make this one invisible. And now if you take a close look here, you can figure that you have the thicknesses of each one. So you can make a break view for each one. For example, for this one, we have a shell here, which is that one. So by using the break view, you can make break view, let's say from here to there to get, and let's minimize the spacing here and minimize the sample size like that. So you can make a break view from here. The same for the bottom one like that. Let's make another break view. I would like to show you how to make a detail for the different thicknesses, which is that one and that one. Let's increase the scale a little bit now, and you will figure out what I would like to say. Let's make the scale 1 to 10, for example. And let's move this a little bit here. And you can figure that you can make a section detail for the blades, for all blades with that scale to define the location of each one. And you can add the weld sample between them. So you can add, for example, select this one and define the fillet weld, this one, and define that one as 8, will be like that, apply. So you can make a detail like that for the longitudinal. Follow the same steps for the below plates, get a section for that one. Now let's check some other points related to the here. Let's go back and check another tool here with SEG, which is here. Let's close this form and close this one. Now let's check another tool, which is SEG Helper. By using this tool, you will be able to generate some pre-built drawings and some pre-built assemblies. For example, if you go to the iLogic drawings, you will find here some pre-built drawings for clean outdoor, manways, and anchor chairs. For example, let's try the clean outdoor. From here, let's select this checkbox and let's generate or select a location for our project, which is day 6, and click on create. Now, if you come back to the location of the project, you will find a detail here for the let's say if we make this one clear like this, you will get a detailed drawing for or a detailed assembly for check that for the clean outdoor. Here you will find a folder here for the clean outdoor detail, and if you open it, you will find an assembly for this one and pre-built drawing for this one. So let's check that. If you try to open this assembly of this clean outdoor, so let's go to the workspace and open the assembly of the clean outdoor. Here you will find a pre-built assembly for a clean outdoor. You can use it to prepare a drawing for all clean outdoors. If you open this form, for example, you will be able to change the size of this clean outdoor with that type of saddle, davit, sorry. So automatically it will be changed based on the dimensions on the API. It's generated by using the iLogic, or it's a tool for programming inside Autodesk Inventor itself. It's not in SEG. So as you can see, the 3D model of this davit now change it to that size. Okay. Now, for example, if you try to open the drawing of this davit, automatically you will get this pre-built drawing, and you can import your title block and border inside this drawing, and you will get pre-built views for that one, and you can just make some adjustment for those parts. Okay, and adjust the dimensions. Here you have the neck plate. Okay, the flat pattern of the neck. You can adjust that and you will find another sheet for the top davit detail. Just you can modify the size from the drawing size. You can modify the sheets here, and you will find detailing description for that on training or tutorial videos on our channel. So you can change the scale of those views. For example, here you have a detail here for the clean outdoor flange and cover. So you can change the scale, let's say for 1 to 12. So the scale of those plates, you can change them or decrease or increase the detail of those. Let's make it 1 to like that. So you can increase and decrease the scale of those items. So from this view, you can make a modification for items. One more thing, you can use it here. If you take a look to the SEG helper, you will find some pre-built assemblies like telescopic crane, mantok crane, and another cranes, some shackles and transportation truck. If we, for example, open the previous project on day 6, for example, let's open that project. Okay, and let's make a quick transportation drawing detail for this one. So how we can do that? So from here, let's select the transportation truck. And let's remove this checkbox from here and come back to that project. Select another location, which is day 7, and click on OK. Now, when you click on Create Project, we will create the truck inside the project of this one. Let's open the assembly of this vessel, and let's open the project here. You will find a new project called here for the assembly. We have the transportation truck assembly here. Now let's create a new assembly and import the transportation truck. So from here, let's open the assemblies, include the transportation truck here, and make it grounded like that. And from here, you can import your vessel. So from here, let's place the sand filter vessel. Now we have the sand filter. Let's make the all UCSs invisible, and let's make a constraint between here and there, like that. Okay. Now you have this vessel constrained to the bottom like that. Let's move it a little bit and center the vessel. So you can figure that it's you can move it right, and so let's select the center plan of this one and make it aligned with the center plan of the assembly like that. So you can move it. You cannot move it right or left, but front and back. So you can define the offset of this facing of this flange from here, let's say, to the facing of the flange. So we can define that as millimeters. So you can make a complete constraint like that. And by using the tools here for wiring, you can use tightening sling. Okay, you will find a tightening sling like that. And from the form of this tightening sling, you can modify the vessel OD. The vessel OD is 3 meters plus 16, so that's the vessel OD. And from here, the vessel offset from the center line, it's 1 like that. So the sling diameter, you can define the sling diameter. Let's make it 15 millimeters, for example. Let's decrease it. Okay, and sling bottom offset. After that, after modifying that, you can save this sling, for example. Okay, so as discussed, to save it, you will need to go to save document as an SEG. After that, you will get that as wire. And from here, you can add that to your assembly by adding this wire. So from external parts, you can add a wire to here. And by using the constraints here and there, you can make tightening wires to and define the location by using the constraints of the assembly. So we have that wire here. You can repeat that along the vessel. And by the way, the truck itself, you can update the assembly of the truck. If you double click on this truck, for example, and open the transportation truck, you can make some modification for the truck orientation itself. For example, if you would like to make it 45 degrees, so the truck back will be rotated like that. Okay, if you would like to study something related to car movement during or truck movement inside the site, you can change the length of the car. So you can decide the length of the transportation car from here, number of wheels, and many information you can decide it from the car information itself. Now you have assembly like that. You can save that assembly from here by saving the active document and come back to Autodesk Inventor as application. Now you can this detail and use it in your drawing as a transportation detail. Now let's change some colors, like make the lighting here as a warm light, or change it as a cold wash out. and changes the scale of this one like this, make it 200 for example. And from here, let's make it shading. And now when you make a perspective view, you will get a detailed view like that for the transportation. Okay, I think now the time of this session is close to end. And if you have any questions before closing this session, we can discuss it during the 5 minutes. Okay, any questions?
Mr. Ahmed, you will have I mean you will provide more time on the detailing of tank.
Again, please.
I'm asking, you will provide, I mean, you will give more time for the tank detailed drawing generation.
Okay, I think we have just 5 minutes, so no time for tank detailing. But we could check something related to the bottom. Let's open the tank projects again. So here, bottom or roof sheet metal development.
Okay, can we open the shell plate drawing that you have developed?
Okay. Just SEG will close the current files and open the new project. Now to open the drawing, you can open it by selecting the equipment node from the tree, and from drawings you can click on open drawing. Now you can figure that the browser tab disappears. So from view to make it appear again, from here you can select browser model to get this form again. Now I closed without saving the other sheet. So from here, let's add a new sheet as discussed, and let's add a view for the assembly of the sheet metal development. It's not saved yet. Okay, to create it again from the assembly, you will need to click on sheet metal development and get the flat pattern for this one. Now it's here. It's just updated if we. Okay, to open it directly, you can open the assembly. I thought that it's not saved, but it's already created. We can open it from the open assembly directly instead of updating it again. Okay, so would you mind to tell me your question?
Yeah, in this shell development, can we have the nozzles to see the nozzles?
I mentioned that it's just approach from SEG Solutions, but no option for opening or access on that one. It's just to indicate the length of each blade, because you have number of blades, different number of blades per each sheet. So to describe the location and the orientation, or the length and orientation of each welding line, we make this approach. And we discussed how to export the 3D model for the second point, which is generating or checking the clashes. We discussed that by creating, already you have a 3D model of this one, and you can easily detect the clashes on the 3D model. Okay, and you can export a 3D PDF for the equipment to refer some clashes for your client, for example, like that you ask him to change the orientation, the welding line orientation, or decrease a little bit the tilted angle of this bracing, or increase it to avoid clashing with the welding line. So that's an approach, not this approach to indicate the length of each blade, not to indicate the holing of nozzles or location of clips. Okay, all of that you can detect it from the 3D model.
Okay. Yes, you're right that all the detection will be done from the 3D model. But
Yes.
What we submit to client is the shell development drawing, and on the shell development drawing, we have to put all the appurtenances to show client that okay, we have this
Yes.
full shell development.
As mentioned, the shell metal development is an old method that you can use it in case of using AutoCAD, but here you have a 3D model, so you can export the 3D model in 3D PDF format, so your client can open the 3D model and check if you have any clashes. I think it's better 100% to use the 3D model instead of AutoCAD drawing. Everything will appear here if you would like to make a section to detect any clashes inside or something like that. You can do that from a 3D model itself. So you can make any representation or indicate any clashes in your model and take his opinion to move or change some things in your 3D model. Okay, so no need anymore for sheet metal development for tanks or pressure vessels.
Okay, we will check this if we can generate a 3D PDF. Okay, maybe we'll try to convince client. Also, we need to see for our site team that
Okay.
with this, I mean, how they will manage. Can you show how you're developing like 3D PDF?
Development what?
You're saying that we can generate a 3D PDF, right?
Yes, we generated for the vessel from here. If you open the file and from export, you can select 3D PDF. But before that, we need to adjust the views. So from here, let's go to the representations. And from the master view, let's select the default view and adjust our default view to that one and make all user coordinate systems disappeared. And now you have this default view. Let's add another view. Let's add a top view, for example. So let's add top view. After that, let's take a look from the top view. So that will be the top view like that. Let's make another view as a clash, for example, clash one. And for the clash one, you can take a close look to this one like that to indicate that you have a clash in this area. Okay, and let's add a clash 2. Okay, so the name of this view will be clash 2, for example, and from here you will take a look down here to this one to indicate that you have a clash in this area. Okay, so you have a different views. First one, the default view, top view, clash 1 and clash 2. Now if you would like to export this to a 3D PDF, now you will need to get export and 3D PDF, and now select the quality of that one. Let's make it low to minimize the size of the file and click on publish. Now Autodesk Inventor will export the 3D view for this equipment inside the project folder. So if we open the project Day6 and for the assemblies, we will get here an PDF file after exporting.
A assembly template for like COD and manhole. So similarly, you have template for nozzles as well.
For the sub-assemblies, you will find here for the pre-built drawings, you can use it for that type of clean outdoor, or that David, or you can use that one, or you can create it directly from SEG as we done. Okay, in pressure vessels, make a group for the nozzle. After that, create a drawing for this nozzle. Here for in that project, we create some drawings for. Sorry. Here we create some drawings for saddle, for manhole detail. Okay, so by the same technique, you can generate a detailed drawing for the manhole all clean outdoor. But here you will find some pre-built drawings to help you in case if you would like to prepare a quick separate drawing instead of making a complete model. Okay.
Okay.
Same for pre-built assemblies. You will find here some pre-built assemblies. You can use them in your in modeling. Here the exporting still working. Now it's on the final steps. Okay, here you will get the 3D model of the tank, so your client can rotate the 3D model and check if anything here takes place for the top and the bottom view. You have the 3D model. Now, if you take a look from the top view or check clash one, so here we make some views to give him an opportunity to check the clashes. If you would like to measure something from here to there, for example, he can measure it easily like that. Okay. And for example, if you select this clash, so he can go and check if you have any clashes or not. Okay, so from the 3D model itself, it's a way to check if you have any clashes or not. And you, by the way, you can make sections during the 3D model. For example, let's add a new view here. Okay, and from that one, let's make a section, half section like that. Okay, to indicate if you have something like internals like that, so it will be indicated on the section view. Okay, so you have a default view without any sections, another view as a top view, another view for clash, another view for section. So you will get so you can indicate that. So if you would like to check something at inside the tank, so easily like that, you have a support or a roof structure camera here intersect with this deep pipe, so easily he can detect that, and you can add a note here for that to give him an indication about that. Okay, so if you have any more questions, kindly drop an email to Image Graphics team, and inshallah we will reply for your email in a short time. And actually we the time of this session is now finished. So any quick questions before ending this?
Yeah, one quick question. This 3D PDF can be opened with Adobe PDF, or we need any special PDF?
Adobe PDF. I'm opening it with Adobe PDF. It's as you can see as the top here. It's Adobe PDF, not another application. Okay.
3D PDF. Okay. Thank you, Mr.
Thank you so much for your valuable time. And actually, I still waiting the training evaluation for Autodesk Inventor and SEG training course. So kindly fill the form of the evaluation and share it with Image Graphics team. I am waiting for that. Thank you so much for your valuable time, and I hope during this the training course of Autodesk Inventor and SEG training course, we cover most of your questions, and I think it will give you a good push to start with your first project in pressure vessels and storage tanks. And inshallah, we will beside you hand by hand. If you have any questions and any support, inshallah, we will be with you too, and we will keep in touch, inshallah. Thank you so much for your valuable time again. Have a nice day. Assalamu alaikum.
Thank you so much. Walaikum assalam.
Thanks, Fauzan, for your support. Have a nice day. Assalamu alaikum.